Describe Democrats.
Gun control, handouts, debt. What else? You want more? Just a general disdain for God and country, in my opinion.
Most of them want to give everything away.
Maybe brainwashed?
I can't describe all Democrats, but it's my learned opinion that the Democrat Party is a crime syndicate, not a real political party.
What are Republicans like?
People that don't have a clue.
Close-minded.
Stuffy. They're mean.
In some sense, some of them are racist.
I've yet to meet a racist Republican where I live or with the people I work with the party, or a homophobic Republican.
Let's talk about something else. How's your YouTube channel doing? Adam's Weather? It's called Climate Adam, actually. And it's doing well. You see, the thing about global warming is that global warming, more like global cooling. Am I right? No, don't get him started. I'm just saying, back in the 1970s, all the scientists were freaking out about global cooling, that the Earth was heading for another ice age. But now they've done a complete 180 and they're talking about global warming. Why should we believe climate scientists when they can't make up their own minds? Well, that's an interesting question. Dude, you can't do that in here. Smoking's terrible for you, and the secondhand smoke is terrible for us. Well, sure. That's what scientists say now. But back in the 1950s, loads of scientists said smoking was great. Okay, very subtle. You're saying that the more scientists learned about smoking, the more they realized cigarettes made us sick, not healthy. Exactly. And the more climate scientists learn about the planet, the more sure they are that we're making it hotter and hotter, not causing an ice age. Okay, sure. But you've got to admit, it's a pretty big U-turn. Everyone in the 70s was saying the Earth was going to cool down, and now they're saying the exact opposite. But that's the thing. Not everyone in the 70s was saying the Earth was going to cool down. What? Well, there were some scientists worried about global cooling in the 70s. But even back then, there was 6 times more research about global warming. Okay, global warming is a thing. Global warming is a thing. But you've got to admit, it's a pretty big U-turn.
Most of them want to give everything away.
Maybe brainwashed?
What are Republicans like?
People that don't have a clue.
Close-minded.
Stuffy. They're mean.
Maybe brainwashed?
Hit me with some common sense here, because if it is as bad as you say, and some of the experts have said, why did we cut this deal? What could possibly be the positives here?
Well, on the president's side, as we all know, he's taken a lot of hits on the international stage. This is the one venue where he could elevate his presidency and perhaps his legacy, which is 2 years away. So he's working on that already. So clearly an international agreement with the #1 country in the planet, and certainly for the future, is a big step up for him. However, if you look at other things that are going on, I think that he's also trying to get his party prepared for the election in 2 years, and an international agreement of this scope supposedly would help there too.
Wouldn't we be a lot smarter, and the president be a lot smarter, if he was getting us ready for what you detail in your book, Dark Winter, and that is the fact that it's going to get colder. This is a global cooling issue that we're involved in here, and this is the sun that is involved. Wouldn't it be a lot smarter if we got ready for that?
Absolutely. I mean, the facts are pretty clear. There is no global warming yet. We've had no growth in global temperature whatsoever for 18 long years now. Now, that's a startling fact, but it's true. And what that means is for most of the time we've heard about man-made global warming, there hasn't been any.
Then why do we continue to hear the phrase global warming? Why does it exist?
There are two components to all of this: the politically correct version of climate change and the scientific factual reality of climate change. They are not the same. They are diametrically opposed. By using the greenhouse gas theory since 1988, the U.S. and other nations around the world have been able to impose new regulations, new controls over people, their property, and the industrial base. When you do that using the greenhouse gas theory, you can get a lot of things done, including taxation, that you couldn't get done before.
Fear porn.
On the science side, however, the sun is the supreme ruler of climate, and it's doing something totally different.
Then why does science always lose in this PR battle to get the message out?
When it comes to power politics, the scientists have always lost. In this case, the scientists pushing CO2 have been tools for the political establishment to get their agenda going. And unfortunately, a lot of scientists have gone over to that side, the dark side.
Good.
Of climate science, and instead of the bright side, the truthful, factual side.
This is our most desperate hour. Help me, Obi-Wan Kenobi. You're my only hope.
They're not telling the people the truth about what's happening with the sun, this potentially dangerous cold climate that's coming, which comes every 206 years, and unfortunately the people are going to pay the price for this diametrically opposed climate situation.
Fear porn.
You're my only hope.
Is it just a matter of being ignorant on the president's side, or just wanting to push something to make somebody else a couple of bucks?
Well, I can tell you from my perspective,
Please.
The president, since he began running, has been well informed of what's happening with the sun and this new cold climate. Clearly, a lot of people know what's going on. We all use the same satellites. We all observe the same sun. There's really not a lot of question about what's happening with the sun.
Hold that thought, because we're going to come back and do a lot more. After the break, more with John Casey. The book, once again, is Dark Winter, and it's more about cooling than it is about warming. We'll explain right here on Midpoint.
You're my only hope.
Now, in the debate, there was a moment where I said these words. I said, temperatures quit rising 10 years ago, but here's what I know. My constituents this year will die in a tornado. Let's allocate resources where we can save lives and property today. Now, of course, after that, and by the way, that 10-year timeline there, I pulled that from the NASA website. But after that pause, it started going up immediately, like the next year, right? And now there's this spike, and then for the last 2 years, it's gone down a little bit. But here's the point: I don't deny the consensus that the climate is changing. In fact, I fully believe and know that the climate is changing. I also know that we human beings are contributing to it in a major way. Carbon dioxide is a greenhouse gas. We're putting it to the atmosphere in volumes that we haven't seen. And that greenhouse gas is warming the planet. That is absolutely happening, and we are responsible for it.
Fear porn.
Children, regrettably, I bring bad tidings. Melting ice here. The North Pole has made our operations intolerable and impossible. And there may be no alternative but to cancel Christmas.
Warming the planet. That is absolutely happening. That is absolutely happening.
That is the fact that it's going to get colder.
That is absolutely happening.
That is the fact that it's going to get colder.
We are in complete control of the planet now.
Good.
I'm meteorologist Chris Holcomb from the 11 Alive Storm Trackers. Predicting the future on a daily basis can sometimes be a challenge. And predicting snow in Georgia is always a challenge. And with this recent snow event, we missed the mark. And our forecast was not absolutely accurate. And for that, I apologize.
Areas of North Carolina that we can't get to. We saw as we were heading out today, a big group of law enforcement with swiftwater rescue boats heading out far, far east, Bill, into the most extreme parts of eastern North Carolina and the Outer Banks there. Talked to some folks out there who said they never see anything like it. They are completely cut off, homes destroyed, boats tossed into front yards, except we just can't show you those pictures because we can't get there either. As for the flooding here, it's expected to continue to...
Nasty as it's been. We had some bands like this last night, and then the eyewall this morning, we were not on TV. It was a dark and raucous night at the hotel, and this wind gusting again over 60 miles an hour. It's blowing by pieces of limbs. This is what we're seeing, a lot of shingles coming off. You see what happens when you throw it off, it just takes off like a projectile. And unfortunately, a tree has fallen on the home here in Wilmington, killing a mom and her infant. The father was transported to the hospital with injuries. So here in Wilmington, New Hanover County, this has become a deadly hurricane now with 2 fatalities, a mom and her infant. Boy, I tell you, look at the wind just whipping the palm trees.
The Weather Channel is now responding to reports that one of their reporters was essentially faking it during his coverage of Hurricane Florence.
Probably seen the video on Facebook as that reporter struggles to keep his balance.
Okay, picking it up here in Wilmington, North Carolina, right at the Intracoastal, and we're in one of these bands.
So that's Mike Seidel in Wilmington, North Carolina. But as he braces and fights the wind Friday, check out the 2 guys who seem to walk right by him in the background there with no trouble at all. The video has been shared more than 1 million times on social media. So now a spokesperson for the Weather Channel is defending Seidel, saying it's important to note that the 2 individuals in the background are walking on concrete while Seidel tries to maintain his footing on wet grass. The spokesperson goes on to say Seidel was exhausted after reporting on air until 1 a.m.
You serious? Fear porn.
Now, by now, you probably already know that CNN is fake news. Well, so a photo just has surfaced on the internet and has gone viral recently that's 10 years old. that proves that CNN has been doing fake news for a while now. Let's look at the photo. Now, as you can see from the guy on the left, there's only a couple inches of rain. Your shoes are barely going to get wet. That's the worst of it. But what CNN did was basically found the deepest part of the water, you know, basically a ditch, and had somebody stand in it. So they could pretend that the whole city is flooded when it's not, and filmed a man inside of it. That way it seems like there's a few feet of rain instead of just a couple inches, which is the reality.
Seeing rescue vehicles going back and forth all day long and still finding people, still bringing people out in the back of pickup trucks, bringing people out in dump trucks. It's also, you were seeing this pets roaming around. Hey, come here. You all right? There's a lot of dogs just kind of roaming around here. I'm not sure if they belong to somebody, if they belong to any of the rescue personnel, but that dog clearly has a collar on, so he belongs to somebody.
So they went from the reality, which is a couple inches of rain, and made it look like a few feet of rain, where you're going to be up to your waist with rain. They didn't exaggerate a little here. They exaggerated a epic shit ton. Where's their integrity? CNN has none. This is the fake news that you watch every single day and your parents watch and believe. Just remember that. Alright, I got another one for you. This one didn't occur today. It happened 7 years ago, but it hammers in the point that a lot of news these days is manufactured.
But first, the severe flooding here in the Northeast as more rain continues to fall today. NB shit.
He says NB shit. You know what? And then he goes and corrects himself and says, oh, I meant NBC. But no, he was right the first time. It's NB shit.
Today, NB shit sees Michelle Kaczynski. I guess she's in the canoe.
Oh my god, the whole city's so flooded that they have to use canoes to get around. That's insane. I hope nobody photobombs her and proves that she's actually in shallow waters. Extremely shallow waters.
It's in Wayne, New Jersey this morning.
Hey,
Michelle, good morning to you.
Good morning. Well, obviously we're getting a nice break from the rain, but not the flooding. This is essentially now a part of the Passaic River in this neighborhood. It rushed in yesterday through the streets, and it's really tough to control a canoe or a boat when you're out in it. It's much deeper back there because this is really...
Actually, Michelle, I'll take it. Is there some kind of severe drop-off there between the foreground? We'll go back. We saw these guys a second ago. Michelle, walking. Are these holy men walking on top of water? What's going on here?
Why walk when you can ride, you guys? When you have a ride like this, why would you want to walk?
Have you run ashore yet?
Well, they wouldn't let me go back into the deep water because they were afraid I would just drift out.
Strange piece of video there, Michelle.
Is your oar hitting ground, Michelle?
Busted! Tell me if you heard this before. An anchorman says the weather's bad, and then two people photobomb the person, proving that it's not. Yeah, this is the third time we're about to see a clip like this. Isn't it obvious that news could be very manufactured sometimes? And you should always take what they say with an ass ton of salt.
We can't get to, we saw as we were heading out today, a big group of law enforcement with swiftwater rescue boats heading out far, far east, Bill, into the most extreme parts of eastern North Carolina and the Outer Banks there. Talked to some folks out there who said they never see anything like it. They are completely cut off, homes destroyed, boats tossed into front yards, except we just can't show you those pictures because we can't get there either. As for the flooding here,
this guy had to be standing in a ditch, just like Anderson Cooper in our first video. Now, do you remember the second clip? The one where the guy is pretending that the storm is blowing him in the wind? Well, a lot of people have came out and done a parody of that today. So let's take a look at that footage.
This is Jill Cantori, reporting live from Florence, South Carolina, where we are under hurricane force winds and catastrophic flooding. It is a bad situation out here, folks. We can barely hang on. We don't know what hurricane force has in store for us at the moment.
It's like kids playing in the street. I love it.
So we are trying to maintain our sanity in this area. Please, folks, take heed to the hurricane warning. Stay inside. Do not come outside. It is catastrophic. We have people dying left and right in hurricane force.
But let's take a look at your forecast for today. Seeing as how it is the last day of existence, as you wake up this morning, man, not bad. 35 degrees out at the airport, 25 in Dalhart. We're 40 in Clayton right now. You do factor in the winds. It does feel a little cooler than that. Not much doing on the radar so far. A couple of clouds well off to the west of us in parts of eastern New Mexico. Some of those clouds have draped in across the high plains. That's why we're a little bit warmer this morning than we have been the last couple of mornings. Now, taking a look at some of the models, they are suggesting a couple of different things for our Mayan apocalypse today. We've got a meteor striking Earth. The magnetic poles are set to flip. All the planets are set to align. I'm throwing this one out. Aliens returning to Earth. I don't necessarily buy that as... I don't like the return to Earth thing. That means they've actually been here before. If this was just aliens come to Earth, I might actually buy that. But so far this morning with return to Earth, I'm just going to go ahead and knock this one out. I don't necessarily believe that one. I'll go ahead and take meteor striking Earth and magnetic pole flip. I'll buy those two. So let's run with that one a little bit further. So what happens if a meteor strikes the Earth? Well, if the meteor strikes the Earth, obviously we're going to heat things up rather quickly later this afternoon, and the magnetic poles flipping means that the magnetic field that keeps all the solar wind from pulling away our atmosphere will be gone, meaning that the solar wind will rip our atmosphere away, which will also increase our temperatures over the next couple of days, and the winds. So keep that in mind as you make your weekend plans and head into next week. Today's high temperatures, 573 here in town as that meteor does strike. We'll hit 573 in Pampa as well. Cooler back off to the northwest a little bit, 570 in Clayton. As you do step off the Cap Rock, you'll be a little bit further away from the sun's rays and a little bit further out of the atmosphere, which means you'll also be a touch cooler. How about 559 for you folks in Clarendon Fort today? Your day planner, well, 26 as you make your way to work, but the winds really do pick up later this afternoon. So do the temperatures. 481 by lunch. Southwest winds at 550 miles an hour. Those will increase to 600 as the solar wind does pick up later this afternoon. We'll top things out at 573, like I mentioned, and we'll cool things back down to 371 by later this evening. Taking a look at the week ahead, 411 for tomorrow. The winds for today will turn breezy as we move into the day for tomorrow. So we're looking at winds today again right around 500 to 600 miles an hour. The solar wind will be back down around 300 to 400 miles an hour for tomorrow. The breezy conditions will continue Sunday into Monday as we do start to cool things back a little bit. You'll notice well below freezing into the overnight hours, down below zero at about negative 200 or so for the, well, foreseeable future. And Christmas Day, 211 degrees, just 112. Bring 4 friends for your day after Christmas, and 240 for your Thursday. All in all, a very warm week ahead. Of course, with the atmosphere peeling away, we'll get up into the 200s in the afternoon, back down well below freezing and below zero overnight. And if you do want more on your apocalyptic forecast, you can do so. Just head on over to myhighplains.com. Of course, that is until the internet disappears as well.
That was awesome.
Nasty is bad. We had some bands like this last night, and then the eye wall this morning. We were not on TV. It was a dark and raucous night at the hotel.
Fear porn.
That is the fact that it's going to get colder.
This warming the planet. That is absolutely happening.
Alright, hello guys, welcome to this video. Today we're going to be talking about grand solar minimum, since I've been getting so many comments about this, and a lot of misconceptions and overhype here. I want to start out by showing you guys this little chart here, 400 years of sunspot observations. Now you'll see the Maunder minimum on the very left and mini ice age. Now this was considered a mini ice age, and it was very cold winters with not so hot summers. That's what it really was. And a lot of glaciers expanded in Alaska, you know, areas like Sweden, Norway, areas like that. Glaciers really expanded. You'll also notice towards the right, modern maximum right here, and this is what we've been in since 1950. We've been getting these really maxed out maximums, and these maximums, what they are, is you'll see this blue line, how it goes up and down. That's our normal cycle. So the bottom is the minimums and the top is the maximums. These aren't grand solar maximums and minimums. These are just minimums and maximums. Grand is when it's prolonged and it completely changes the cycle. So these are the normal cycle deviations, I guess you could say. And you'll see we're approaching the modern minimum that's expected by 2020 or 2050. So somewhere in that time frame we're expected to arrive, and it will probably last around 50 years. Now, what exactly does this mean? I did a little drawing here on this chart, and you can see the red is where the maximums peak out at, and the blue is where the minimums are at their minimum. Notice that the blue doesn't change whether we're in a minimum or a maximum. That's because usually minimums are already at 0 sunspots per day, or just near it. So there's not really, you can't go lower than 0. So the minimums will not change. Just to name a few, minimums was 2009 to 2010 winter, 2010 to 2011, very cold winters. Also a few of the early 90 winters. Winters like that were minimums. And I'm going to show you guys in a minute my anomalies that I compiled of all the minimum years and how those winters ended up being. But here under the modern minimum, you'll notice I made that purple zone. That's where the maximums will be. There won't be any maximums, or barely. There will barely be any maximums. So it'll always be kind of like a minimum. We'll be almost at 0 sunspots most of the time, similar to the Maunder minimum here, where you see those red X's. There's barely any that go any higher than just 10 or 20 per day, which is very low. So here's my anomalies of the minimum years, and you'll notice that it's very cold basically the entire United States. This is because some years were warm in the east and some years were warm in the west. Some years were cold in the west and some years were cold in the east, so it averages out at just cold everywhere, because where it was colder than it was warmer where it was warmer, if that makes any sense. I know that's kind of a tongue twister, but it will still be warm on one half of the United States almost every year, warmer than average, and it will be colder than average on one half of the United States almost every year. That will not change. There will still be troughs and there will still be ridges. That's really important. That's a misconception I hear. Everybody thinks that it's going to be colder everywhere. That's just not the case. There's still going to be above average areas. Now, here's a little closer look at our solar cycle. Here's solar cycle 23 and 24. So at the solar minimum after solar cycle 23 is when it was the 2008, 2009, 2010 winters, very cold winters. And then we had this little bit of a maximum. See, it peaked out right around 2014, but this maximum wasn't very strong, so we had a lot of colder winters in there because it wasn't very much of a maximum at all. You see, we're approaching a normal minimum. Whether the grand solar minimum is approaching or not, we are approaching a real minimum where there will be under 10 sunspots per day most likely. Now, this means that we will have some of those colder winters most likely. I am a believer in the sunspot activity and how that correlates to colder winters. A lot of people aren't, and a lot of people think that I don't believe in that. I do believe in that, and I've seen it with my own eyes, like the winters of 08, 09, 010, or yeah, so things like that I have noticed. So I am a believer, unlike some people. Now, I don't believe that the grand solar minimum will lead to these insanely cold winters from the west coast to the east coast, and everywhere is going to be cold and all that, because a lot of comments were on my winter forecast, which is interesting because I called for very cold temperatures and polar vortex over the Great Lakes. I'm calling for a very cold winter where it's going to be cold. The problem that people have is that I'm calling for warmer on the west coast. Whether it's grand solar minimum or not, there's going to be a warmer area, and that's just where it's going to be. So we're approaching a possible grand solar minimum. We don't really know when it's going to be, but we know that the maximums have been getting smaller. Weakening solar cycles since cycle 21 peaked around 1980. You can see all the maximums are smaller. So like I said in that illustration that I drew for you guys, those maximums are going to get smaller and smaller until they're almost non-existent. And then there won't be any of those warmer solar cycles. So I hope this cleared up a lot of questions that you guys had, and a lot of the people who have heard a lot about the solar maximum and solar minimum and grand solar minimum and that. This is my take on it. It's really a unproven science, and it's all speculation at this point because we don't really know how much of an impact it has, and it's really debatable. But this is my take on it. And whether you guys like it or not, there will be a warmer area every winter. There will be an above average area during the winter. So my forecast completely correlates with if there's going to be a solar minimum. I've taken that into account, and that's what my forecast is also taking into account. Anyway, I hope you guys have a great day.
When we think about the climate and we're thinking about the energy of the climate, it's essentially all coming from the sun. There's no other source of energy. The amount of energy coming out of the centre of the Earth is tiny. So all the energy that's forcing the climate system is coming from the sun. So when we're thinking about what causes climate change, it's quite interesting to think about how changes in the sun, or indeed the solar radiation reaching the Earth, can affect the climate. The first thing to think about is the Earth's orbit around the sun. So that is not in a circle, it's in an ellipse.
So remember, that yellow dot, which is a point on the equator, it's got to be travelling at a constant speed. 1,000 miles an hour around the circumference of Earth, and 67,000 miles per hour around the sun. If that changed in a short time, we'd notice it. So the big question is, how's this been missed? Well, given that the Earth moves at constant speeds as it spins, and we don't feel anything. So that's then put in a box, and we're told that constant speed is now travelling at another constant speed around the sun. So by putting the constant speed in a box, you just think constant speed, and then another constant speed. So it all makes sense. We need to take them out of the box and work them, see how they work together. And when they work together, this is what we get. For us to feel no movement, all speeds must be constant in all directions.
Doing a constant speed. So what's constant speed? So we could be travelling at 67,000 miles an hour, 500 miles an hour, 80 miles an hour. If that speed's constant, like on this train, you feel no movement. But if that constant speed changes over a short amount of time, by 3 miles an hour a second, no matter what constant speed we're doing, we'll feel it the same at every constant speed. So we'll treat this train as Earth journey around the sun. So don't forget, I'm travelling at the same speed as the train. So if I move my hand towards the front of the train, my hand moves faster than the train. If I move my hand to the back of the train, my hand is slower than the train. But don't forget, if you're on a globe spinning, you're spinning, and as this point rotates, it's moving towards the front of the train. At this point, it's moving towards the back of the train. And as we're constantly rotating and moving forward, you're accelerating and decelerating as it rotates. So that's Earth travelling at 1,000 miles an hour. So imagine we're doing 67,000 miles an hour and we're on the ISS. So we're doing 67,000 miles an hour that way and we're rotating at 17,000 miles an hour around Earth. So these points represent the ISS spinning around Earth. As we get to here, we're travelling at 17,000 miles an hour faster than the Earth is travelling that way. As we get to here, we're travelling at 67,000 miles an hour faster that way, so we're going slower by 17,000 miles an hour than Earth.
Look at the animation. This is showing the vectors as the half of the rotation. The red dashed line shows the resultant vector of the two vectors as it rotates. And note it gets bigger as it rotates. This shows that we're getting faster as it rotates. That point on that rotation is moving faster as a result of those two vectors.
And it goes further away at some times of the year and then nearer and then further away again. And of course there's more solar radiation getting to the planet when the Earth's nearer in. At the moment that's happening in about January and the furthest away is in about July. But that varies on very, very long timescales, so like about 100,000 year timescales, that very, very slowly evolves the eccentricity of the orbit.
You serious?
Another factor that is responsible for the distribution of radiation over the globe is of course the tilt of the Earth's axis to the plane of the orbit. And that will result in the development of seasons. So when we have the northern hemisphere tilting in towards the sun, it's northern hemisphere summer and southern hemisphere winter, and when we have the other way round, it's southern hemisphere summer and northern hemisphere winter. So we have the amount of solar radiation distribution over the globe is varying dependent on that. That tilt of the orbit also varies on tens of thousands of year timescale. The final and the third parameter which affects the amount of radiation getting to the Earth in terms of orbital parameters is called the precession, and that's telling us at what point on this elliptical orbit the northern hemisphere is pointing in towards the sun. At the moment, the northern hemisphere is pointing in towards the sun when it's at the furthest point in the elliptical orbit. But that parameter, that timing, also varies on tens of thousands of years. So we have these three parameters that are determining the Earth's orbit around the sun, and they will influence the amount of radiation that's coming from the sun onto the Earth, and also its distribution over the Earth.
Now here's another tricky bit to do with something called radiative forcing. Wikipedia explains that radiative forcing can be used to estimate a change in surface temperature arising from that forcing. For solar irradiance, the radiative forcing is the average amount of solar energy absorbed per square metre of the Earth's area. But because the Earth is a sphere, the area exposed to the Sun is only a quarter of the total surface area of the Earth, so the total input per unit area is only 1/4 of the change in solar intensity. But because the Earth is a sphere,
this new surface-to-surface photograph was taken at a record long distance of 326 miles or 529 kilometers. The previous record surface-to-surface photograph shown on the Beyond Horizons website was 443 kilometers or 275 miles. The new photograph we are going to look at today was from 326 miles or 51 miles further. Here is a Google map of where the photograph was taken. What makes this even more amazing is the fact that the target island location was only a height of 85 feet. The photograph was taken on top of this peak at an elevation of 3,212 feet or 979 meters. Here is the target location. It is an island off of Corsica with an elevation of 85 feet. You can add another 40 feet for the lighthouse. Here is the record-breaking photograph. You can see the little white lighthouse on top. The viewing direction also lines up with the photographer and the city in front, but you can watch the original video to see how everything lines up. According to the globe model, the target hidden height at an observation height of 3,212 feet and a distance of 326 miles is, and are you ready for this? 43,848 feet. The top of the lighthouse would have been only 125 feet above the water, and you can see it in the photograph 326 miles away. That is just impossible under the globe model. 43,848 feet should be hidden behind the curvature, and you can see a lighthouse at only 85 feet above the water. Like so many other observations, that ocean is flat. Ergo, the Earth must also be flat. Thank you, Nouvelle Géographie Planetaire, for sharing this amazing flat Earth proof. Thank you.
Put the dump valve all the way to the rear. Put the dump valve all the way to the rear. There it is. There's the world out there. There it is. There's the world out there.
Elephant.
Whoa. Whoa. There it is. There's the world out there.
Because the Earth is a sphere, warming the planet. That is absolutely happening. And
that is the fact that it's going to get colder.
One suggestion was that when there was more sunspots on the sun, there would be less radiation coming from the sun because the black spots would be blocking out some of the radiation. Perfectly plausible hypothesis. But when they were taking these radiometers up mountains, there's a guy called Abbott in the United States going to really clean areas up mountains, trying to get long records of solar radiation, trying to relate it to sunspots. He couldn't do it, and of course he couldn't do it not because there's anything wrong with his instrumentation, but really because of the atmosphere in the way it just blots out quite a small signal. Since we've had satellites, of course, we've...
Scientific ballooning, the best kept secret in space science.
This is the list of all balloon launches from the Esrange Space Center in Sweden. You see this, people? What does that say? Mir. That's the Mir space module. February 24th, 1997. Here goes another one. Mir. March 17th, 1997. Mir. Okay? I want you to see these things. Here we go. Two more. Mir. February 18th, February 19th, 1999. Mir. It's the Mir space module, people. On a balloon. The ISS does not exist complete the way they show it on television. Here goes another one. Mir. On a balloon. What they are showing you of the space station is a computer-generated image. They are not showing you the complete module put together, flying at 17,000 miles an hour. Here you go. Look at this. Support Mir. They sent up a support balloon to resupply the Mir on a balloon. On a balloon, people. Look at this. Orion payload. Look at here. Inmarsat. You want to know where your satellite phone communications come from? A balloon, people. A balloon. I'll supply this document to whoever wants it. Here we go. Inmarsat test. Balloon. If you were to take time to search every single one of these flights to match it up with a particular rocket launch that they claim this thing was on, I guarantee you, you will be able to compare it with this Swedish Esrange Space Center balloon flight list. Balloon flight list. Balloons, people. That's your program. It's always been your program. Look at this. Mir short duration. Mir VLD. You got 2 VLD, and look at here. More Mir. This is in 2002, people. 2002. For those in Europe, you ever heard of Enviasat? Look at Enviasat. Enviasat. These things are supposed to be testing the atmosphere for particulates and, for pollution control. Balloons, people.
Because of the atmosphere in the way, just blots out quite a small signal. Since we've had satellites, of course, we've known that solar radiation does vary, and it varies in phase with the sunspot cycle and in phase in a positive correlation. So when there's more sunspots, there's more radiation coming from the sun. When the sun is more active, it not only produces black sunspots, well, they appear black to us, but it also produces brighter areas that we can't see with the naked eye, but can be seen in various cameras. And the brighter areas, the effect of the brighter areas dominates over the effect of the darker areas, so that there's more radiation coming out of the sun when it's more active. So I've mentioned solar flares, which are very intermittent on very short time scales. Well, they vary on century time scales, but they also vary on a very well-known 11-year cycle. So you've heard of the sunspot cycle, and there's a certain amount of effort that goes into understanding whether the weather and climate vary with an 11-year cycle. Another indirect measure of solar activity is actually cosmic rays. So if you're looking at galactic cosmic rays, these are coming from well outside of our galaxy, but they're coming to the Earth all the time. The arrival outside the solar system is fairly constant, but when the sun is more active, its magnetic field strengthens and the cosmic rays are deviated. So there's an indirect so that there's an inverse relationship between the number of cosmic rays and solar activity. So if we have a measure of what the cosmic rays were doing, we know what the sun was doing. And we have a measure of what the cosmic rays is doing in the cosmogenic isotopes, clues in the name.
It's that there are like Lego bricks from which everything in the world is constructed. These Lego bricks are particles, and the particles are the electron and 2 quarks. It's a very nice picture. It's a very comforting picture. It's the picture we teach kids at school. It's the picture we even teach our students in undergraduate university. And there's a problem with it. The problem is, it's a lie. It's a lie. It's a white lie. It's a white lie that we tell our children because, we don't want to expose them to the difficult and horrible truth too early on. It makes it easier to learn if you believe that these particles are the fundamental building blocks of the universe. But it's simply not true.
So we can see if we look back in climate history, we will see a record of the change in solar radiation in the climate. And the most obvious example of that is the existence of ice ages. If we look at how the ice ages have occurred, they occur on approximately every 100,000 years. We're fairly sure that they're due to changes in the eccentricity of the Earth's orbit around the Sun.
That point on that rotation is moving faster as a result of those two vectors.
So we can see if we look back in climate history, we will see a record of the change in solar radiation in the climate. And the most obvious example of that is the existence of ice ages.
You go to school or college and take courses that deal with the ice age, the evolutionists or the uniformitarian scientists make it sound like, hey, the ice age is one of their best examples of slow processes over millions of years. They say first of all, they said there were 4 ice ages. I mean, that was dogma for 60 years. But suddenly they looked at it differently, and now there's about 30 ice ages that repeat every 100,000 years. And then, but you go back past 1 million years, they repeat every 40,000 years, to the point where in the last 2.5 million years you have about 30 ice ages. This is what they say. And it may make it sound like, oh, you just need a few degrees of cooling and man, there's the ice age. It's not like that at all. In fact, the ice age is a major mystery of science, as I will tell you, and only the Bible can really explain it. Now that sounds like a strange title, but just bear with me. I will show you how it relates. It's not directly in the Bible. It's an inference, a strong inference from the Bible. But first of all, I told you a little bit about millions of years. I want to say something very quick about dating methods. They have a lot of different dating methods, but it's mostly mainly the radiometric dating methods: uranium, lead, potassium, argon, rubidium, strontium, isochrone method, these sorts of things that they tout as being so accurate. They're not that accurate at all. In fact, we're doing our own dating. In the Grand Canyon, we have the Cardenas basalt and the vast diabase, and they're dated about 1.7 billion years old by the rubidium, strontium, isochrone. Those are igneous rocks, and you date the time it cools. Well, up here in the northwest rim of the Grand Canyon, you have a lot of fresh-looking volcanoes, and the lava's come down and kind of has stuck to the walls. So the Institute of Creation Research has said, well, we're going to date those rocks by the same methods that they dated this lava at the bottom of the Grand Canyon. And what? Guess what? Lo and behold, you get dates older, that the time of cooling is 1.34 billion years old by the same method, the rubidium, strontium, isochrone method, which is considered one of the best. 1.34 billion years old when it cooled, when yet it cooled within thousands of years. It's older than the lava supposedly in the bottom. Something's wrong somewhere. We've done this over and over again. We're dating modern lava flows and getting millions of years, like Mount St. Helens, the dome in Mount St. Helens, some lava flows in New Zealand that are within 50 years. So something's wrong somewhere. So Institute of Creation Research has this big research project where they're trying to find out why. And they're sort of leaning towards the idea that there's accelerated radiometric decay during the creation and or the flood. But you'll hear more about it. They got one heavy book out, which I don't think we have back there, but you have to know something about geochronology to read it. It's called the RATE book, Radioisotopes in the Age of the Earth. They're going to have a second book out in 2005 and a layman's version of it. I'm going to be really interested in how they can make this all a layman's version. That's going to be the biggest challenge of all, because it's really heavy stuff that they get into. But I have a personal reason why I'm skeptical of dating methods. As you know, I was a weather forecaster for 30 years. And I did this many times. Today's weather forecast, 100% chance of sunshine. Does that ever happen in the Seattle area? And it dumps on you. In fact, that's why I became a weatherman. I said, I'm tired of with all these wrong, lousy weather forecasts. I love to hike in the mountains and backpack. And it rained on me when they said it wasn't. Well, guess what? I got sucked in and I did it myself. But anyway, the point of this is, tell me again why I should trust scientists' ability to be accurate about about life on Earth millions of years ago. I mean, I think some of these, when you read geology, they make it sound like when they're describing things of millions of years ago, billions of years ago, that they were right there. They could tell you about the soils, the climate, and the ecology, and the animals, and whether it's a marine environment, a terrestrial environment. I mean, it goes on. And they don't say likely or probably. They say that's what it is. But they had to forecast the weather for at least 1 year, and I don't think they would be making statements like that too often. But anyway, let's get into the topic. This is an overview of my talk. Now, ice ages are divided up into what's called pre-Cenozoic and Cenozoic. These pre-Cenozoic ice ages go back to 2.2 billion years in their scheme. I'm talking about their scheme. And I'm going to make a case that these are actually gigantic submarine landslides during the flood. Those are the pre-Cenozoic ones. And I'm going to make a case that a Cenozoic ice age did occur, and it's a major mystery of science. The climate change caused by the flood really initiated the ice age. There was only one rapid ice age, and ultimately, only the Bible can explain the ice age. That's what I'm going to be talking to you in the next 45 minutes. Okay, if we want to learn about past ice ages, I mean, there's no ice to observe. You know, what do we do? Well, we go to where there's glaciation right now and see what glaciers do. What kind of work do they do on the rocks? What kind of features do they produce? Well, good place for this is the Athabasca Glacier up in between Banff and Jasper, up in the beautiful Canadian Rockies. This is the glacier was here in 1890. That was the front of it, and practically all glaciers of the world have been receding, except for some in Scandinavia. And I think it's a combination of a little bit of global warming and a little more power coming out from the sun. And if you want to know, get off on a tangent, if you want to know my opinion on global warming, I think it's 10% reality and 90% hype. Now, that's all I'm going to say about it. I could talk a whole hour on that. But we need research. We need good research into it. We've got to figure out, first of all, how significant is it? And number two, is it harmful? I got a postcard I'm going to get on PowerPoint that shows a committee in Montana where there's a shack out there, and it's snow about that deep. They're all standing around like this, and it's called the annual meeting of the Committee for Global Warming. The question is, we don't know if it's going to be harmful. Let's find out. It'll be harmful in some ways, but other ways it'll be beneficial. So is it the benefits going to outweigh the harm? We don't know that yet. We need more research. I'm for more research. But anyway, when the Athabasca Glacier backed up, it left telltale signs. See all these rocks mixed in with finer grained particles of sand, pebbles, silt. That's your typical features you see. It's called glacial till. And they formed shapes, geometric shapes like this. This is an end moraine where the glaciers pushed the rock out and formed a mound in front of it. It's called an end moraine. Right in here is called a lateral moraine where it pushes the rocks to the side as it moves out. See, the glacier continues to move out as it melts. And so if the melting is more than the pushing out, it'll recede throughout the years, and that's what's happening at Athabasca Glacier. And here's a picture of the lateral moraine as you walk up into the ice sheet. I don't recommend this to too many people. This is loaded with crevasses. You can look down there and woo, wow. A nice hole down in the clear ice. It'll go way down there. Anyway, look at that sharp lateral moraine with the stones of various sizes in it within a finer grain matrix. Also, another feature it does is as rocks on the bottom of the glacier move along the bedrock, it scratches the bedrock, and the rocks in the glacier get scratched. So a lot of scratched rocks. See all these nice scratches on the bedrock? Here's a stone that's scratched, and it's scratched in two different directions at least, going this way and this way. It's because the rock turned while it was scraping the bedrock. Those are typical glacial features. And here's a scratched and grooved bedrock from the Sperry Glacier in Glacier National Park. It's been receding also. So those are typical glacial features. So you look around the Earth where there's no glaciers today, and you look for features like that if you want to discover past ice ages. So the evolutionists have done this and all over the Earth, and they've categorized the past glaciers into 4 general categories. This is a big question mark right here. I'm not going to speak of that. This is in hundreds of millions of years right here. So this is 250 million years. The MZ stands for the Mesozoic. Anyway, I'm splitting these down into two sections. I'm going to talk about two sections, pre-Cenozoic ice ages and what they call Cenozoic. Now, it has another term called Pleistocene or Quaternary. They're synonyms for the ice ages that recently ended according to their time scale. So I'll divide it right in here. Now, you have four main ones in there right in here. These are all abbreviated. Time goes this way. This one, early Proterozoic ice age, occurs about 2.2 billion years ago in Ontario, Canada. The late Proterozoic one is a very interesting one. It actually spans a long time. It's about, they say, about 550 million years to almost 900 million years. It was about a 450 million year long ice age. And so far, I'm not going to talk much. The late Paleozoic was one that is in many places in the southern hemisphere. You find them on all the continents in the southern hemisphere, these deposits. They're hard rocks, like you see a cliff and you see these rocks in this cliff. Well, what kind of rocks trigger their idea of an ancient ice age or a pre-Cenozoic ice age? Well, such features as this. This is a picture from Ontario, Canada, showing what's called the early Proterozoic ice age. It's stones like this within a finer grained matrix of sand, silt, and maybe even clay floating in there. This is lithified. This is cemented rock. And that is what they consider, only ice ages can form a pattern like that, is what they used to say. Now, I'm going to tell you that there's other mechanisms that can do that, but I'll get into that. Also, you find these scratched rocks. This is the late Paleozoic striated or scratched bedrock below what's called tillite. Now, tillite is hardened till. This is hard. This is hard material here. It's rock. But in that rock, you find stones of various sizes and compositions within a finer grain matrix, and above it you find the scratched pavement, very typical of ice age features. So they do have evidence for these ancient ice ages. This one would be dated about 300 million years ago. Okay? However, there's problems with all these pre-Cenozoic ice ages. Number one, when you find something they say that they believe is an ice age, you find a warmth indicator next to it, like dolomite or carbonates. They're usually deposited in warm water, dolomite and hot water. How can you have hot water indicators and cold indicators next to each other or above or below? Big problem. Also, practically all these deposits I'm talking about are marine. But most times we see ice ages on land and they deposit on land. Why are these marine? Well, maybe it's because they were deposited by something different than ice ages in a marine catastrophe. Hint, hint, hint. Anyway, there's features you'd expect in a glaciation that are missing from these deposits. Also, that late Proterozoic ice age, as I said, was from 550 million to 900 million years in their dating scheme. They find the deposits of this mostly at the equator or near the equator or the paleoequator. And they're marine, meaning that the ice started on the pole and it descended to the tropics, covered the equator, and went all the way down to sea level. What does that mean? That's a totally glaciated Earth. So now they dubbed it Snowball Earth. And you know, that's the time when the origin of life is occurring. So they kind of boxed themselves in a corner. How is life going to evolve when the Earth is totally glaciated? And from a meteorological point of view, if you totally glaciate the Earth, chances are you're never going to unglaciate it because the reflection of sunlight from that white snow and ice is going to keep it cold. So they got some big problems with this Snowball Earth. Also, in the Sahara Desert, where there is the main evidence for the late Ordovician ice age, the grooves and striations which is the main evidence, is they're all going in the same direction, all over North Africa. About 2,000 miles wide, they're all going north. No ice age produces striations that consistent. In fact, even in a short distance, the striations on bedrock go this way or this way. They're different. This is consistent with what is called mass flow over a huge scale. And that is exactly what I believe is the cause of these so-called pre-Cenozoic ice ages. I believe they were mass flow, landslides, debris flows. There's lots of terminology, but it's like a landslide. It moves, and And I believe it happened during the flood, so they moved long distances underwater. In fact, here's a landslide deposit in Montana, near Arley, Montana. You can see the till-like signature of rocks of various sizes in a finer grain matrix. Here's one on top of the Gravelly Range mountain, same signature. They used to think this was an ancient ice age, except when they found out they dated it at the Eocene era. That's an era of great warmth, so they had to axe that so-called ice age because it was a warm period. But up there in the top of the mountain at 10,000 feet, you find scratched bedrock and even these chatter marks where a stone is bouncing in the ice and makes a groove every few inches like that. They used to claim that this only forms in ice ages. But here we got a landslide deposit that did it. In fact, here's some of the debris you see right down here. Here's another picture of it, some of the grooves and striations on the bedrock, and here's a scratched rock, duplicating what many used to think was an ice age deposit, evidence of ice age. But this is a landslide deposit. To make a long story short, I did an in-depth study. It took 11 years, and I published it in the book Ancient Ice Ages or Gigantic Submarine Landslides. Of course, this would be the submarine landslides are during the flood. And if you want to know more about it, you can get my book. You might notice that the cover is different. That book, when it was first printed, and I got the first edition back there, was dark, and there's a bunch of typos in it. Actually, not too bad. So I have it back there at reduced price. It's normally $21. I want to get rid of these first editions. I was very unhappy with them. The second edition's a lot better, but anyway, $15 for a cut rate on those. Now let's get back to what's called the late Cenozoic. I talked about these pre-Cenozoic ice ages, making the case that they're not ice ages at all, that they're actually gigantic submarine landslides that duplicated a number of what was thought to be ice age features in the past, but now a lot of scientists have come around to realize, hey, landslides can do this. Let's talk about the late Cenozoic, what they call the late Cenozoic or Pleistocene or Quaternary. I'm going to ask 3 questions in regard to this. First of all, do these deposits really represent ice ages? That's the first question we ask. I mean, let's find out if they're ice ages before we try to explain it with an ice age mechanism. Number 2, can an ice age occur in the present? Is an ice age easy in the present climate? I say present because the uniformitarian scientists rely on present processes to account for the past. So they got to use present climatic changes to account for the ice ages. That the remnants of the ice age right now are Greenland and the Antarctic ice sheet, but I'll show you. This area was glaciated during the ice age. There's some nice ice age features in Puget Sound area. The third thing was there more than one. They claim there were up to 30 in the late Cenozoic, 30 ice ages in regular succession. Okay, in dealing with the first question, you go to the areas where we feel, or they feel, it was glaciated, and look for glacial signs. Well, you know they're all over the place. This is west of Great Falls, Montana, where I lived for about 28 years. And here's the Rocky Mountains. The Rocky Mountains up in here were glaciated. Glaciers came out of valleys, and they formed distinctive features, like this end moraine. This is a typical end moraine. Here it continues over on this side where I took the picture, and you can see it's stones of various sizes piled up. And here it was breached, probably from when the ice melted, it breached the end moraine and flattened it out. Then I went and looked at part of the end moraine, and lo and behold, it was stones of various sizes in a finer grain matrix, typical of glacial features. This is a place that gets up in the lower 80s in the summertime, where the idea of ice ages not that long ago just seems totally unreal. And then when you go up into the canyon, the Sun River Canyon to the west of that, you find the scratched bedrock. This is a cliff 800 feet high right here, the first cliff before you get onto the high plains, and look at the scratched bedrock you find there from a past glacier that went up and over the cliff. And here's some of the rocks you find in the end moraine down there, scratched rocks of at least 2 different directions. And then closer to home here, in the Wallowa Mountains, and in a lot of other mountains of the western U.S., the mountains of the western U.S. were mostly glaciated, the Sierras, the Yellowstone. This is the Wallowa Mountains. This is a beautiful lateral and end moraine, a small end moraine and a big lateral moraine forming a horseshoe shape. in the northern Wallowa Mountains near Enterprise. Enterprise is out here about 4,000 feet above sea level. It gets up there in the 90s in the summer. And over-deepened lake, typical of glaciers that go down channels or valleys. They tend to over-deepen valleys. Beautiful. That lateral moraine is 600 feet tall. Very sharp looking, indicating that the ice age was not that long ago. And yet the idea of having an ice age here just seems totally unreal. Then when you look at the material in the lateral moraine, yeah, it's a typical till signature with rocks of various sizes in a finer grain matrix. So the conclusion is that, yes, this place was glaciated not that long ago. And then you find these erratic boulders here and there. And this is one of the most famous erratics, 30 miles southwest of Calgary, Alberta, called the Okotoks erratics. Very sharp. They didn't roll. This is quartzite. That had to be drifted down on an iceberg, and it probably came from around Jasper National Park. Carried long distances just sitting out there on the plains. No quartzite outcrops on the plains. This guy for scale is John Woodmarape, who wrote that great book, the feasibility study. And then when you add it all up, this is what it adds up. It was glaciated about 4,000 years ago in the creationist time scale in these areas. Right in here. Here's the northern boundary. Some of the mountains in the west were glaciated. But guess what? Look at that. Where a place we'd expect to be glaciated, the lowlands of Alaska, were never glaciated. And that's where you find those millions of woolly mammoths. I got a book coming out on that from Master Books this fall called Frozen in Time, Woolly Mammoths, the Ice Age in the Bible. And we get into that. That's a whole different talk. I don't want to get off the subject. Anyway, in Europe, this is the corresponding ice where the ice was in Europe. Most of England, northern Germany, northern Poland, etc., into northwest Asia. The Alps were glaciated, and the central mountains of Asia were glaciated. That's where we find it was glaciated not too long ago. It includes the Puget Sound area. You go along the beach in Puget Sound, you can find a lot of scratched boulders. So the question, do these deposits really represent ice ages? I would say yes. There's no way you can account for these by landslides because it's over too flat of terrain. Central and eastern Canada are very level. There's no way you're going to get this whole area just covered with glacial till by a landslide. So there was a huge climate change that did this. Number two, can an ice age occur in the present? Well, first of all, we've got to figure out what kind of conditions do we need for an ice age? What are the requirements for an ice age? Well, the first ice requirement is obviously cooler summers. Like, I mean, if you wanted the ice to come back here, you got to cool off the summers. Now, in this place, winters are too warm still, but most areas where the ice occurred are already cold enough in winter. That's not a problem. In fact, you'd like the winter to actually be warmer because the warmer the air, the more the moisture it holds. So warmer winters would really help an ice age, but cooler summers, you especially got to have cooler summers. Number two, much greater snowfall. Much greater snowfall. And number three, it has to persist for many years. If you could find a climate change that caused a cooler summer, that may be possible, but it's got to persist year after year, and it's got to build up and build up to form an ice age. Well, how much cooler? Well, a guy did a computer study in Canada, and he found out, well, I want to ask the question, how much cooling do I need as summer cooling? How much do I need to cool those summer temperatures in Canada off to get 1 inch of snow to remain, winter snow to remain until the fall? That was the question, just 1 inch. So he cooled it off by increments of 2 degrees. So when he cooled it off 10 degrees, this is where the 1 inch of snow persisted. 12 degrees, that's in centigrade, that's 20 degrees Fahrenheit. That's where the 1 inch persisted until the fall. Just 1 inch. Only there. 20 degrees Fahrenheit, that's for northeast Canada. But the ice was clear down south of the Great Lakes. You need much greater cooling. How much? Well, let's take a city like Minneapolis. The average temperature in the summer there is 70 degrees Fahrenheit. That includes your max and mins, and divide by 2, that's 70 degrees. Now in Antarctica, the melting doesn't just start at 32 or anywhere, especially in spring and summer, because solar radiation is the most powerful energy source for melting snow, not temperature. So it's the solar radiation which is powerful in the spring and summer at mid and high latitudes. Well, in Antarctica, they observe that net melting occurs when the temperature warms up to 14 degrees Fahrenheit. If anybody that lived in North Dakota or Montana, we have these spring storms, they'll dump snow, and the sun comes out and it rises to 10 degrees Fahrenheit and the snow starts melting at 10 degrees Fahrenheit in the spring. So net melting is at 14, but I'm going to be conservative and say Minneapolis summer temperatures had to drop to at least 20 degrees Fahrenheit for net melting. That's a change of 50 degrees Fahrenheit for the summer. Where are we going to get that in present processes over millions of years model? You're not going to get it. There's no way that they could even think of it. Therefore, the Ice Age is a major mystery of science. And here's a series of quotes in 1957 from the giant book. It's a 1,600-page book. In fact, that's a quote from page 1,532. It's called The Quaternary Era by Charlesworth. He says, the Pleistocene phenomenon, that's Ice Age phenomenon, had produced an absolute riot of theories. Yes, at the time of this writing, there were 60 theories of the Ice Age. Kind of competes with the theories on the demise of the dinosaurs. They have about 60 of those, too, that are very entertaining. But they range from the remotely possible to the mutually contradictory and the palpably inadequate. That's not saying much for those uniformitarian theories. Oh, but that was in 1957, and we know so much more now. We do? Well, here's 1996 in the popular journal Earth, which is now defunct, I believe. Daniel Pendick said, if they hadn't actually happened, the ice ages would sound like science fiction. And in a 1997 issue of U.S. News and World Report, August 1997, they reported on 18 great mysteries of science. These are their best mysteries of science. It's kind of entertaining when you go through that, because some of these mysteries are mysteries of their own making because they believe in evolution. Like what happened to the dinosaurs? Well, they died in the flood, except for those that were on the ark, and they died out in the cold climate after. But notice this one. Can you read that one there? Why do males exist? Well, why is that such a mystery? Well, because in evolution, everything should reproduce asexually. The idea of having a male and female just can't figure it out by evolution, you know. But of course, we have an easy answer. In the beginning, God made them male and female. It's just so simple from the Bible. So these are problems of their own making, but some of them aren't. One of them is what causes ice ages. It's considered the top 18 problems in science. And just recently, David Alt, in his book Glacial Lake Missoula and its humongous floods. By the way, I think there's only one humongous flood. But anyway, he says, although theories abound, no one really knows what causes ice ages. So ice ages are a major mystery. How do we explain it? Well, here's how we explain it. The flood not only produced all those vast amount of fossils and sedimentary rocks, it perturbed the climate. You probably had a warmer climate before the flood. And during the flood, you caused conditions that would have a climate change afterwards, called a transitional climate, until you got to the present, right in here. And well, what are those features that perturb the climate to cause an ice age? Well, here they are. The volcanic dust, see, the flood was a gigantic tectonic event with crust moving up and down, and also a lot of volcanism. In fact, I think they estimate 25% of sedimentary rocks are probably originated from volcanoes. Anyway, at the end of the flood, you'd have all these volcanic dust and aerosols. And aerosols is a fine-grained particle. Aerosols cause cooler summers over land. In other words, the sunlight reflects back from these and cools the land, especially the mid-latitude continents, mid and high-latitude continents. It doesn't affect the ocean, by the way, because of the heat capacity of the water. Number two, the fountains of the, I thought I corrected that. The fountains of the great deep and volcanism caused the oceans after the flood to be a lot warmer. This is a very key feature. Warmer water, the warmer the water, the more the evaporation, by a considerable amount. So we had warm water from the bottom of the ocean to the top, from the Arctic Ocean to the Antarctic. In fact, you might have been able to swim in the Arctic Ocean right after the flood. It was that warm. And that would produce so much evaporation at mid and high latitude, right next to where the ice sheets were building. That's your tremendous moisture supply, is that warm ocean. And the mechanism will persist until the volcanism decreases after the flood and the oceans cool. And here's an example of how the reflection of sunlight back to space works, like this. Now, there's one slight problem in this is that volcanic ash and aerosols filter out of the stratosphere slowly, 1 to 3, 1 to 5 years. So you need to replenish that volcanism with time. And that was done after the flood, and the evidence we have of that is the tremendous evidence of volcanism in Ice Age sediments. And on deep sea sediments from the Ice Age period, you have lots of evidence of volcanic ash. So it was a very volcanic period that would replenish the aerosols and the ash in the stratosphere to keep the Ice Age going. Charlesworth says, signs of Pleistocene or Ice Age volcanicity and earth movements are visible in all parts of the world. Now, the evolutionists know that volcanoes cool the earth. I mean, we've observed this in the last 200 years with the big eruptions that have gone off. Not Mount St. Helens. Mount St. Helens was a little eruption, believe it or not. But Mount Tambora, Krakatoa, there was a huge eruption. Pinatuba and others. They cooled off about 1 degree Fahrenheit over the whole northern hemisphere, or a good part of the northern of the world. So we know it cools. But why can't they see this as a cause of the Ice Age? You know why? It's because of their time scale. Their time scale is stretched out so much that we're talking about several 100,000 to 1,000,000 years where they have this volcanism they observed in the Ice Age period, to the point where it's insignificant. But we telescope it within a short period of time, it becomes very significant. You know, I'm finding out in all I do that time is a key factor. Our short time scale is a key factor of solving major mysteries of science. Major mysteries, our short time scale. Time is not a side issue in the creation evolution issue. I'm finding it very crucial for solving major challenges, major mysteries of that they can't explain. And on basic meteorology, you can, because of the general current winds going from west to east, you can figure out where the major evaporation areas are, and they're generally on the east coast of continents, and in the Arctic Ocean is where they are, and that's just exactly where the ice built, real close to that major evaporation for the ice sheet over North America. And you can figure out major storm tracks just by basic meteorology, because the storm tracks generally follow the areas where you have the strongest horizontal temperature differences. That's just basic meteorology. That's where your jet stream will be, and the jet stream guides the storms. And so you can have some general storm tracks. You're going to have one major storm track south of the ice sheet, because the ice sheet's cold and it's warmer over land, so it's going to follow like that. Then the warm ocean right out in here, and then you get the cool land and ice sheet's going to cause another storm track out in here. Then when it gets out in here, it's going to lose what it's called its thermal support, and they're going to break up and go all which directions. These are average storm tracks. Now in meteorology, chaos theory usually reigns, so you're going to have storm tracks, a lot of different ones, but these are average storm tracks. Now this storm track here is the northeaster storm track that really blasts the East Coast every winter with snow that deep. And I would say you probably would have northeasters with the temperature staying constant like this for years and years. You'd have maybe a northeaster every 2 weeks. And they'd be huge northeasters that dump huge amounts of snow. So you can have a rapid snowfall. So the Ice Age would occur rapidly. How rapidly? Well, here's my evidence for that it was a rapid Ice Age right here. This is it, Jenkins. Indisputable proof that the Ice Age caught these people completely off guard. There's my evidence. Now let's get serious. The Ice Age will quit when the controlling mechanisms slow down or end. And the main one I found was a cooling of the oceans. Once the oceans cool, they don't evaporate enough moisture to keep feeding the ice sheets, because they do have some melting in summer. And so melting in summer becomes more powerful to the point where they build up to a maximum and then they melt. So it was actually a very simple calculation. I mean, in theory it was. The variables were speculative. I'll get into that. It's simply the heat balance equation of the ocean. And I use the atmosphere too, because the heat went into the atmosphere. If you take the heat inputs, subtract the heat outputs, that gets your change in temperatures of the ocean. So it's a simple equation, heat input minus heat output equals change in temperature. You can think of it like a box. You heat up that box, and then you have some cooling of that box, and the difference between the two is the change in temperature within the box. They're called heat budget equations. So that's what I used and estimated on the variables. Now the variables, it had to be during an Ice Age climate. and it was started with a warm ocean. There's no way to be precise. So all I wanted was a ballpark figure of how long was the Ice Age. Was each Ice Age 100,000 years, as they claim? They claim each Ice Age is 100,000 years. Well, but in our calculations, I use minimums and maximums for the variables. See, I wanted to bracket, minimum, maximum. I just wanted a ballpark figure, and that's what I did. First of all, I had to figure out what was the average temperature of the ocean at the start of the Ice Age, what was the average temperature of the ocean when it peaked. And I used 30 degrees centigrade as the average temperature of the ocean. And I used a figure of 10 degrees centigrade for when it peaked, and it started to melt in this right in here. The average temperature of the ocean right now is 4 degrees centigrade. So when it was still 6 degrees warmer than today, I believe that it peaked. These are estimates. They can be played with. So that represents a 20 degree centigrade drop in the ocean temperature, or a 38 degree Fahrenheit drop. Of course, I give it away right here with the figures I got when I used the budget equations. In these equations, time is one of the variables, and that's why I can figure out the time. So here's my ranges. I got a range for the quickest, 297 years, and the slowest, 1,765 years. The best estimate I figured was 500 years for glacial maximum. Then you had to figure out how fast it melted, you got to figure out an average depth. And so I had to use the moisture source. The main moisture source is the evaporation from the ocean. But there's other moisture sources. Moisture coming from the subtropics and the equator up into the high latitudes. So I used these, and I got a range for here too. I used ranges, maximum, minimums. The best estimate was an average of 2,330 feet for the northern hemisphere. Now, some places would be thin and some places thicker. I think New England was a lot thicker, but up where I live in Montana and Alberta, the ice was a lot thinner. In fact, you know that because the Cypress Hills were sticking up out of the ice, and the Sweetgrass Hills were sticking up out of the ice. So you can calculate the depth, and it was very shallow. In fact, it's so shallow, it was shallow along the edge of the ice sheet that the uniformitarians have a problem of moving it because it moves by its surface slope. They can't move it from the north to the south because it's so low. Well, in this Ice Age model, it doesn't move. It will move, and it generally moves from north to south, but it generally grows in place. It generally develops right in place. And here's the range for Antarctica, I figured. Then on the melting, solar radiation is the main mechanism for melting, and a lot of it's reflected back to space. And when you heat up the top layer to 32 degrees Fahrenheit, then you start the melting. It'll form rivers on top of the ice, and it'll percolate down until you get to the layer that's below 32, and it'll refreeze down here. But you'll still have a net melting. That's how it melts. I use the energy balance over a snow cover. It's the most scientific way you can to melt snow. And here's the estimates I got. I use ranges for the variables. For the edge of the ice sheet, or the periphery, I got a minimum of 40 years and a maximum of 100 years. The best estimate was 70 years. The time to melt the interior of the ice sheet was about 200 years. So the total time for a post-flood ice age is 700 years. So this gives you an example. When you use different initial conditions, the results are totally different. We don't need 100,000 years. We only need 700 years, which fits in just great within the biblical time scale. Not a problem at all. So the questions, can an ice age occur in the present? No. Then I go to the question, well, they say there were many ice ages. Do we have many ice ages of 500 years or 700 years long? No, actually, there was only one ice age. Oh, excuse me. I believe there were two ice ages. Two ice ages. Now, there was one before the flood. And this was in the area of the Garden of Eden. And it was right after creation, and this is the first ice age. Eve, why are you acting cold towards me? Did I do something wrong? You figure it out, Adam. You know? These problems have started ever since Genesis 3 between man and woman. There's kind of a communication gap. I'm not going to say anything more about that because I think my wife is still here. Anyway, I'm going to go real short on this. You know, the idea of multiple ice ages is mainly an assumption. guess it was first of all, it took them a lot to really believe in an ice age, because an ice age was so radical, it seemed to be against uniformitarianism. Well, it is. So they said, but the evidence is so strong that we have to believe in an ice age. But to make it sound like uniformitarianism, that they're really easy, they said, well, we had many of them, one after another, so it was just no big deal to have an ice age. Well, in the journal Geology, they found out in Alberta, where they used to say there were 3 or 4 ice ages, they now say there's only one. Glacial reconstructions commonly assume a multiple glaciation hypothesis in all areas that contain a till cover. And notice the title of this, A Single Late Wisconsin Laurentide Glaciation Edmonton Area in Southwest Alberta. They believe in only one ice age, and it was in their late Wisconsin time. There was none before that in their time scale. Also, to account for some of the few places, they did see what looked like a till, sand or clay or some organic matter, then another till, and it did appear to be like there were 2 ice ages in some spots. Very small areas. Most areas show evidence of just one till cover, one ice age. That can be explained by one till here. This is a little bit hard to follow. I'll translate it for you. In fact, maybe I'll just summarize it for you. Many multiple successions can probably be explained, and he tells about the sand between 2 tills. They can be explained by the former presence of subglacial melt streams under the ice, coupled with shifting ice divides and changing ice flow directions. This is all within one ice age, one ice sheet. So you can account for even that data that they think is for evidence for multiple ice ages. You can still account for it within one, and they admit this themselves. These guys are evolutionists, by the way. So in summary, the ice age is really a mystery of the present processes over millions of years model. Noah's flood caused a transition climate for the ice age. The ice age lasted about 700 years. We don't need 100,000 years for an ice age, and we don't need 2.5 million years for their 30 or more ice ages that they claim, since there was only one ice age. And ultimately, only the Bible really explains the ice age. And you've probably heard that in the 70s, we had a little cooling trend.
No, don't get him started. I'm just saying, back in the 1970s, all the scientists were freaking out about global cooling, that the Earth was heading for another ice age. But now they've done a complete 180 and we're talking about global warming. Why should we believe climate scientists when they can't make up their own minds?
And they said, oh, the ice age is coming soon. I don't know. Some of you might remember that I got 3 books on that topic, and there were lots of journal articles. But they're also thinking that the next one's due real soon. In fact, if anyone saw that movie, The Day After Tomorrow, they actually have another theory on the ice age, and that's global warming causes the ice age. It's really funny. I wrote a review in the July impact article for the Institute of Creation Research on that movie. Where warming causes an ice age. You know, it's total baloney. There is a little bit, I can't say total, there was a little bit of grain of truth in it, but it was, anyway, if you want to read more about that, look at the July Acts and Facts from the Institute of Creation Research. Anyway, in the New York Times, this guy said this about a year ago. If the past is any indication, the Earth is at the end of another such warm period, poised to descend into a new ice age. Are you fearful that, this area was glaciated. Are you fearful that the ice age is going to come here in the next couple of years? I can see some people they're starting to get nervous and shake in their boots or their tennis shoes. But I can assure you, the Rainbow Promise assures you there'll never be another ice age, because God said there will never be another flood. And the flood caused the ice age. Therefore, there will never be another ice age. So you can cancel all that out of your mind. And I could see the relief on all your faces.
The fact that they're not harmonic and smooth and sinusoidal as you might expect in these very slowly varying orbital changes is an interesting question.
Well, that brings us to an issue that a lot of people has to do with ice cores and the dating associated with those ice cores. What has your study shown?
Well, first of all, ice cores are made generally in Greenland and Antarctica. That's where they come from. It's a very large amount of ice there, and it's basically maintain itself the whole time. Cores are taken by drilling about a 6-inch to 8-inch core down through the ice, drilling down all the way down to bedrock at the bottom and pulling them out very gently, maintaining them in cold conditions so they're preserved. And then you look at the detail in the ice through that long length. The ones from Greenland are about 4,000 to 5,000 feet long, the ones in Antarctica up to 9,000 feet long. And in there you have visual layers that you can look at that were formed as the ice compacted and went from snow to ice, and it maintained the bubbles that are in there. It has various chemicals that are in there, dust layers that are in there, looking at oxygen 18 isotope ratios. From all of those various features, you can see the variation with time down through the ice core as it accumulated material. For one thing, is that you would expect there to be one ice age following the Genesis flood. And you see that in the record. Where most of the evidence is presented that there were multiple ice ages is at the very bottom of the core, where it's the hardest to interpret. And it shows that it was disturbed very strongly down at the bottom of the core, as well as the fact that there was all kinds of dust and chemicals and features that you have a very difficult time trying to interpret. If, in fact, the Genesis flood was caused by a catastrophic event and it produced all kinds of volcanic eruptions and the Earth's surface being disturbed greatly, you would expect to see that at the bottom of the core, and that's exactly what you find. And it's not just a small, thin layer down there, it's up through quite a depth through at the bottom of the core. So that fits very naturally with the Genesis flood idea with the catastrophic process that occurred there.
But now we want to see actually whether these changes in the sun have any effect on the climate. One, can we detect any signals in climate that correspond to these changes in solar activity? Two, can we explain them? So it's a sort of statistical question and it's a physical question. In terms of statistics, I've talked about the cosmic ray records of longer term solar activity, and we can compare those with temperature records, proxy temperature records that we have of global temperature. And we can detect some small correlation. For a long time, there was the idea that the Little Ice Age, as it was called, in the late 17th century, in which the temperatures, especially in northwest Europe, were cooler, corresponded to what was called the Maunder minimum in sunspots. So that was a time when no sunspots were observed for a period of perhaps 50 years or so. We know that it wasn't just because people weren't looking, or that they weren't trying, or they weren't seeing them, because they were measuring them before that. They were trying to see them and they couldn't see them, and then they were seeing them after that. So it was actually a depletion in sunspots occurring. So there's this sort of correlation between the Little Ice Age in temperature and the Maunder minimum in sunspot activity, and it's been a sort of trope of the whole science area that these two are linked. Actually, a new idea, which is possibly going to put a spanner in the works, is that we now understand that there was a lot more volcanic eruptions around the time of the late 17th century, and in fact it's probably the fact that there was more particulates in the air from the volcanoes causing the cooling as opposed to lesser solar activity. So actually we're getting, it's a more complicated picture than was previously understood. That being said, what about the 11-year cycle? Well, there are measures of 11-year cycle variability in a number of different climate records. The most obvious of which is up in the stratosphere, and you can see 11-year cycle in stratospheric temperature and in ozone concentrations. Nearer the surface, there are 11-year signals. It's quite difficult to extract. They're quite small and the statistics is difficult, but it does seem that there are indications, particularly in the North Atlantic region, where we seem to get colder winters when the sun is less active on the 11-year cycle. So we've got these indicators of various climate effects. Another one is Pacific Ocean temperatures in the tropics, which seem to be surprisingly cooler when the sun is more active. So if we think the statistics are correct, we now need to understand the physics of what's going on. We can understand the global temperature, surface temperature, these very, very small changes of perhaps 1 or 2 tenths of a degree in response to changes in the solar radiation, purely from radiative forcing ideas or just from energy balance ideas. But if we want to understand these more regional effects of solar activity, we need to look a bit more carefully at the physics of what's going on. One very interesting aspect is, of solar variability is that although the total radiation is changing over the 11-year cycle by perhaps a few tenths of 1%, so a very small amount, actually that's not the same at all wavelengths of the solar spectrum. So that's true in the visible, where of course most of the energy in the solar spectrum is coming in, but in ultraviolet wavelengths the variation is much larger. So if you go from say 300 to 200 nanometers wavelengths, you find that there's several percent variation in solar radiation over the solar cycle. And if you go to 100 nanometers, getting further away in the UV, it's doubling between solar max and solar min. So clearly this is an interesting physics question. What happens to this UV? We've got the big changes in the UV. Where is it absorbed in the atmosphere? Well, it's absorbed in the upper atmosphere. And in particular, the slightly closer UV, the 300 to 250 nanometer wavelengths, is absorbed in the stratosphere. And we can see changes in temperature in the stratosphere. We can see changes in ozone in the stratosphere, which is very interesting in its own right, but that doesn't tell us about the climate of the surface. So current work is very much focusing on coupling between the different layers of the atmosphere, the stratosphere and the lower atmosphere, the troposphere, and also coupling between the troposphere and the oceans as to how some of these apparent solar effects take place. We can now understand that changes in the stratosphere can affect the surface climate through changes in the winds and the circulations. And then there may be a knock-on effect of the wind stress on the oceans producing some of the observed ocean effects. So this is really where a lot of the current research is going on. In summary, changes in solar radiation reaching the Earth, either because of the sun's variation or because of the Earth's orbital variations, is fundamental to our understanding of climate and climate change. And we need to understand that in order to be able to be more certain about human activity and how that's affecting the climate. Very important for understanding the effect of the sun on the climate, of course, is knowing what the solar radiation is doing. And we now have satellite instruments that are flying up there, measuring the solar radiation, measuring the spectrum of solar radiation, right the way from X-ray through to the far infrared. So these measurements need to be carried out with extreme precision and also, importantly, with a stability that allows us to know whether or not the solar radiation is varying. And these satellite experiments have...
In Viasat, these things are supposed to be testing the atmosphere for particulates and, for pollution control. Balloons, people.
Been in the UV for perhaps a couple of decades, but the ones that are going into the near UV and the visible have only been going since about 2003. And the technology is not quite good enough yet.
Balloons, people.
But it's being developed all the time, and it's really exciting to see how the data that they will provide will give us extra information into the future. When we have these data, we can then use them in our models of atmospheric chemistry in the stratosphere, of the climate models, and see how the temperature effects affect the upper and lower atmosphere and how that couples to the oceans, potentially to the ocean circulations, and we can have a much better picture of how the sun affects the climate.
You serious?
Warming the planet. That is absolutely happening.
That is the fact that it's going to get colder.
A chart that's often produced to suggest a large cooling effect of a grand solar minimum is this one, showing the solar cycles going right back to 1600. Between 1645 and 1715, there was an event called the Maunder Minimum. The Maunder Minimum was a prolonged period when very few sunspots were observed. It corresponds with a period of lower winter temperatures in Europe and North America, and as a result it's sometimes cited as being the cause of what's known as the Little Ice Age. But according to paleoclimate reconstructions, the onset of the Little Ice Age occurred between 1560 and 1600, at least 50 years before the beginning of the Maunder Minimum. Winter temperatures didn't go down significantly more when the Maunder Minimum did kick in, and actually the summer temperatures throughout the Maunder Minimum were very similar to summer temperatures in subsequent years. In fact, according to this 2012 paper by Miller et al., the best current hypothesis is that the Little Ice Age most probably came about largely as a result of volcanic activity. This report from Carbon Brief tells us, at first glance, solar forcing seems to make intuitive sense. The sun is a massive nuclear fusion reactor, 1 million times larger than Earth. It is responsible for almost all the energy reaching our planet, and in the past few decades scientists have learned that solar activity varies significantly over time. Indeed, changes in the distribution of sunlight reaching the Earth clearly change the temperature dramatically on a daily and annual timescale. However, since 1970, global temperatures have shot up by almost 0.7 degrees Celsius, while the amount of solar energy reaching the Earth has actually declined. Similarly, the upper atmosphere is cooling while the lower atmosphere warms, a clear fingerprint of warming from greenhouse gases rather than the sun. This chart, based on a paper by George Fulner and Stefan Rahmstorff, published in Geophysical Research Letters in 2010, shows how our planet's temperature would most likely be affected by a grand solar minimum as severe as the Maunder Minimum. The red line shows predicted temperature change for the current level of solar activity, and the blue line shows the predicted temperature change if solar activity went all the way down to the level of the Maunder Minimum. The black line shows observed temperatures from the NASA GISS dataset through 2010. The authors found that the average global surface temperature would be diminished by no more than 0.3 degrees Celsius, even at the very lowest solar activity. So even the grandest of grand solar minimums comes nowhere close to compensating for the warming that human CO2 and other greenhouse gas emissions will cause.
It's never actually been fully proved, and that's the other disturbing thing about that State of the Climate report in 2017 is that it actually didn't prove a whole lot. I'm going to show you a graph here. This is the global average temperature in comparison to CO2. And the report, and I've read it several hundred pages, basically what the report is saying is that the only thing that correlates with temperature rising is CO2, and it is a direct correlation. But I want you to look at these dates a little closer and look at those graphs a little closer. What you're going to notice is that they don't correlate. In fact, there are multiple periods where there were decades of miscorrelation between CO2 and temperature rise. This isn't a political issue. I think that a lot of people think that I have some sort of political angle here. Republicans, Democrats, Libertarians, all alike, have policies geared towards man-made climate change, mitigating our CO2. And so they're all under this belief system that CO2 is causing global warming. The only science in the report that I have found to be relatively accurate in observation is that CO2 radiates heat. That means that CO2 actually takes heat in our atmosphere and radiates it. It carries it for a longer shelf life and increases the thermal temperature in that capacity. However, it doesn't create the heat. And the other interesting thing that I found in the CO2 science is that when CO2 increases as a gas, its thermal radiation of heat is actually more of a chemical reaction. It has more to do with the way the molecule moves.
CO2 is a rod, and it bends like this, up and down, up and down. And it's that bending motion that causes global warming. But that is such a strong absorption that it's saturated now. So as you add more CO2, most of what you can do has already been done. There's still a little addition, but not very much. There's an interesting thing about CO2, which is unique to CO2. It's not true, for example, of water vapor or methane, and that is that if you get 1 degree of warming from doubling CO2, so going from, say, 400 parts per million for simplicity to 800, that doubles it. Mm-hmm. Suppose that causes 1 degree of warming. Then to get another degree of warming, you have to double 800, so you have to go to 1600. So you have to double it again. So it gets harder and harder to warm. Technically, they call that the logarithmic dependence of temperature rise on CO2 concentration. It was first guessed at really by Svante Arrhenius, who did some of the earliest work on global warming. He thought it was good, he was all for global warming. But he was the first one to point out this doubling property of CO2. He didn't even know about spontaneous emission yet. It was before Planck. But nevertheless, he guessed it correctly.
So to see a 1 degree increase in heat from CO2, we actually have to see CO2 double in volume. It's not based on a per volume basis. In other words, temperature doesn't rise every time we go up 100 parts per million. It has to double in volume for the temperature to rise 1 degree. I believe the overall consensus is that CO2 will double, and therefore we will go up over, a degree Celsius, or, some people think it's 3 degrees, whatever it is, but they think that it will go up once the CO2 has doubled. So let's get into the carbon cycle, and I've seen a lot of different carbon cycles, a lot of different carbon budgets. The UN uses one, the Department of Energy uses one. Collectively, they are not the same, which to me tells me that there is a discrepancy in the science, one that is a discrepancy that nobody can prove, and that is the total emissions of CO2 that come from our planet. What they have determined is that, and I'm going to use the Department of Energy's map. I like it. It's easy to understand. The percentages are approximately the same. It's the numbers that change. So the Department of Energy has this carbon cycle budget and description. And basically, if you look at it, what it's showing you is that as a whole, we have about 210 gigatons of carbon dioxide emitted into the atmosphere every single year. 9 gigatons of that carbon dioxide comes from the burning of fossil fuels and man-made activities. So that's not just burning of fossil fuels, that is deforestation, that's creation of concrete. When we break up the limestone, we're releasing CO2 into the atmosphere. So that is 9 gigatons of CO2 a year on the Department of Energy's map. And like I said, there could be some more updated ones, but they all correlate about the same approximately in percentages of CO2 going out, CO2 coming in. What this shows us is that the Earth is consuming approximately the exact amount of CO2 that is emitting. But the Department of Energy actually shows that the Earth is taking back more CO2 than what is naturally being emitted. So without mankind, according to this chart, we would be going down in CO2 each and every year. The problem is when you look at the Industrial Revolution and the time frame in which people were able to start producing CO2 and emitting it, CO2 is already going up. So it makes me question this carbon cycle scenario that we see out there and wonder if it's actually even consuming any of the man-made CO2, or if there's a different discrepancy there that they're not disclosing, or that they don't know. A lot of this, I think, is just stuff that they don't know. I think this is a hypothesis guessing game that has gotten a lot of traction. It's very popular, so let's go with it. The big thing that I was wondering when I was looking at the carbon cycle is the percentages of the amount of carbon that we as people are putting into the atmosphere versus Mother Nature. And it's ironic how in these carbon cycles, it all shows this direct correlation. Everything that is naturally produced is naturally consumed, and then a little bit of human emissions is consumed, but not much. Human emissions at 9 gigatons is 4% of the overall CO2 emissions of the planet. According to the 2017 report, CO2 drives temperature, and according to that report, there are no external forcings on temperature other than man-made CO2. To completely grasp what it is that they're saying, you would have to believe that there are no external forcings on CO2, that this cycle on planet Earth is completely systematic all the time. And it's not true. If you look at the UN CO2 cycles, they have completely different numbers for emissions from the planet and how it's interacting with our planet. Why? Because they were done at different times and those numbers change. Our planet changes. Oddly, the absorption rate of CO2 seems to go up the more CO2 there is. So at 4%, how much can we really impact our planet? Can we double the CO2 in the atmosphere in and of ourselves? That doesn't make a whole lot of sense. I mean, CO2 has doubled off of a 4% contribution, and it's not even a net 4% contribution, it's like a net 2% contribution. There has to be other external factors affecting CO2. Logically, there's got to be. I'm going to show you some news articles that have come out recently, and this is how misleading and misguided this entire science has become. So the Arctic is on fire. We know this. We can see it in satellite images, and the big thing that everybody's been saying about this is the amount of CO2 that those fires are putting into our atmosphere is making our CO2 challenge even worse. It's horrible. It's an astronomical amount of CO2. Here is a chart that shows how CO2 was emitted during forest fires in California. Now, we must be causing these fires because we're heating up our planet. We just had the hottest June on record, and that's what set these fires in the Arctic. I want to introduce you to ice bore data. This is the data that they are able to get from ice bores and different glaciers throughout the planet. And what they have determined, and there's been a lot of recent studies on this, is that prior to the Industrial Revolution, there were a lot more fires on our planet, a ton of fires, and they can see this in the black carbon and the ice cores. The question I have then is, number one, I thought there weren't any external forcings. I thought Mother Nature didn't contribute to CO2. We're now saying that fires are a feedback cycle of human emitted CO2, but yet there were more fires before the Industrial Revolution than there are now. And part of that has to do with land management of mankind. The third question I have is, if there were so many fires pre-industrial period, why did the level of CO2 in the atmosphere not read higher in the ice core bore data? I mean, it was going up, but it wasn't going up astronomically. And if these calculations are correct of how much CO2 these forest fires are adding to our atmosphere, wouldn't that make the rate of CO2 climb through the roof? And wouldn't that have drastically increased the amount of CO2 in our atmosphere pre-industrial? There are already answers to these questions. CO2, the properties of CO2 are extremely thermal. One of the things that was in the 2017 report when talking about external forcings on temperature, they brought up forest fires and volcanic activity, and they brought them into the equation as 100% negative factors on temperature. Why? Because of the amount of aerosols that they're producing. Now let's look at the Arctic again. Look at the amount of aerosols that are now filling above the Arctic. If this is a net zero temperature effect, what is that going to do to our Arctic? Is it going to warm it? No, but the news media would like you to think it's going to warm it. They would like you to think that our CO2 emissions are now going to climb even faster and higher. And scientifically, that has not happened in the past. Scientifically, it has not happened in the present, even with man-made fossil fuel emissions. If you look at charts from 2002 and beyond, our fossil fuel emissions have skyrocketed. They've gone through the roof. But the rate of change in CO2 in and of itself has stayed relatively the same. It has continued to climb at relatively the same rate. So CO2 and its growth, the way that our atmosphere holds it, the rate in which CO2 fills in the atmosphere, does not correlate with forest fire CO2. It does not correlate with fossil fuel emitted CO2. It does not correlate at all with the emissions of CO2, which I think is extremely odd. And that should get everybody questioning this entire model. What is making CO2 rise in our atmosphere if it is completely unaffected by the substantial increasing of other forcing events, other forces that are bringing CO2 into the atmosphere? It is a very, very pondering question that I have spent a lot of time researching. And there is one explanation that I have found that makes complete sense. Temperature. The rise in temperature makes all the difference in the world on CO2. What else do we learn from ice core bore data? We learned from boring into the ice, pulling the cores, that CO2 levels lagged temperature. This threw a lot of people off. I mean, this was something that just, I mean, we cannot accept that science. Even though it's been bored in ice for centuries, we cannot accept the fact that CO2 follows temperature. That's insane. But if we think about CO2 and its thermal properties, and we look at thermally induced CO2, now this is something that you don't hear a lot about because it disproves the human-induced CO2 theory altogether. But they do mention it in feedback cycles because it's one of the largest feedback cycles. So it's hard to offer feedback cycles as a scenario for increased CO2 due to human emissions without offering thermally induced CO2. And that is, as the atmosphere heats and gases are able to expand, you have additional CO2. It's a gas. The higher the temperature of the gas, it's going to have different effects on the CO2 itself. CO2 is a property that is almost completely manipulated by heat and temperature. So it doesn't surprise me that if you look at the rate of change of thermal CO2, it more accurately matches the rate of change of CO2 in the atmosphere. Now, you can blame this on a feedback cycle on human emissions CO2, but human emissions CO2 has gone through the roof, and the rate of change in CO2 has remained the same. Furthermore, we get into temperature in and of itself. In comparison, the rate of change in temperature and the rate of change in CO2, the rate of change in temperature deviates from the rate of change in CO2. In fact, what we have seen is the rate of change in temperature seems to be decreasing regardless of the rate of change of CO2. I played a clip for you earlier explaining that CO2 has to double for it to actually have a 1 degree impact on temperature. So there has to be other external forcings on temperature. It's not like temperature is just following CO2. What we've seen from the core data from boring into ice, what we have seen from just logically reasoning through the amount of forest fires pre-industrial versus now, and the amount of CO2 that those forest fires, because I mean trees are carbon, it's a different type of carbon fuel, but it's still releasing CO2, carbon dioxide. So what we have seen is that the releasing of CO2 in and of itself does not correlate with the rate of change of CO2 in our atmosphere. The other thing that we realize from the carbon cycle is that everything is made out of carbon. We eat carbon, we're made out of carbon, the trees are made out of carbon, the ground's made out of carbon, everything's carbon. And CO2 is recycled carbon, and it makes its way back into the earth and reforms as some form of carbon. We're not increasing the amount of carbon at all. It's a fixed number, it's just changing forms. It's one of those things where you can't exceed the demand of CO2 before the supply is there. So the supply increases and the natural demand increases. There's a very big argument that while CO2 and temperature don't necessarily exactly correlate, the human population and CO2 correlate very closely together. And that is true. The more humans we see on Earth, the more CO2 we see going up. You know, we are made of carbon, we eat carbon, everything we need is carbon. But the question is, does the supply exceed the demand, or does the demand exceed the supply? And looking at every other species on our planet, their growth rate has depended on the supply, and humans are no different. If we didn't have the agricultural capabilities that we have, we wouldn't be able to populate the amount that we have. If we didn't have the energy resources that we have, we wouldn't have been able to populate the amount that we have. So the CO2 supply was there before the demand. It enabled the demand to follow.
Will cause.
But you've got to admit, it's a pretty big U-turn.
Most of them want to give everything away. Maybe brainwashed?
Will cause.
Welcome. I'm afraid I have some very bad news for the Grand Solar Minimum cult. Solar Cycle 24 is alive and well, and we aren't anywhere near solar minimum as yet. So what is the problem? The problem is sunspots, and far too many of them. We shouldn't be getting this many sunspots if we're anywhere close to solar minimum. And a new set of sunspots emerged this last week in active region 2733. Here's a plot of the sunspot number over the last 13 years. And at the moment we are here. Fairly close to solar minimum, but not there yet. This is a picture of the new region, active region 2733. And as you can see, there's quite a large number of spots there, including a large leading spot. The sunspot number is officially up to 30 at the moment, but I can see at least 45 spots, so I suspect that number will increase. The region just produced a C flare, which is the largest flare for quite some time. and that would make more C flares quite likely. Well, active region 2733 is definitely an old cycle region. How can we tell? The negative polarity, that's the black polarity here, is leading, and the positive polarity is following. That's the signature of a solar cycle 24 region in the northern hemisphere. So solar cycle 24 is still producing large and strong spot groups. That is not a characteristic of solar minimum. Well, let's take a look at the movie of the flare. This is the region shown in the 131 angstrom band of the AIA instrument on the Solar Dynamics Observatory. Here comes the flare. Very pretty. And that flare was a long duration event. It lasted a couple of hours, so therefore may well be associated with a coronal mass ejection. Now that's in the part of the sun that could eventually affect the Earth, so we may be looking out for some aurora in a few days' time. So why is all of this such bad news for the grand solar minimum crowd? Well, first of all, it means that solar cycle 24 is still alive and well. We haven't yet reached the solar minimum between solar cycles 24 and 25. That will not likely occur until much later this year or even next year. So all the extreme weather that they've been attributing to the effect of the grand solar minimum can't be associated with it because the grand solar minimum hasn't started yet. In fact, the solar minimum hasn't started yet. I hate to kick somebody when they're down, yet we have more bad news. There's already signs of solar cycle 25. The three ringed areas here are reverse polarity sunspot regions. And so consequently, that means that solar cycle 25 is beginning to appear. Now that's very early. It could indicate that solar cycle 25 will be larger than solar cycle 24, which is the exact reverse of what the grand solar minimum people have been predicting. So let's see if we can draw this together into some sort of conclusion. First of all, solar cycle 24 is still active, so we're not at solar minimum yet. So none of the odd weather that we have been having can be attributed to the onset of a grand solar minimum or even the onset of solar minimum itself, because neither of them have happened yet. We're also seeing the first signs of solar cycle 25, which is unusually early and means that a grand solar minimum is very much less likely. So if you hear somebody spouting on about a grand solar minimum, just tell them that they're full of nonsense and post a link to this video. Until next time, goodbye. Welcome. It's been a very quiet couple of months on the sun recently, and it's prompted many people to ask, are we at solar minimum yet? This video explores that question. Perhaps we should first discuss what solar minimum actually is. It's the lowest point in the smooth sunspot number between two adjacent solar maxima. The smooth sunspot number is generally smoothed over a 12 or 13 month period. I generally prefer the 13-month version. And thus you cannot know when solar maximum actually was until at least 7 months after, and if you're wise, you wait for at least a year in case the sunspot numbers go back down again. So what are the most obvious characteristics of solar minimum? Well, obviously there have to be few or no sunspots for long periods of time. The sunspot groups themselves are small and short-lived. There's a mixture of old and new cycle regions on the sun. The old cycles appearing somewhere near the solar equator, and the new cycle regions at high latitude, say above 30 degrees. And also if you look at the outer corona of the sun, it has a relatively simple structure. As I said earlier, we've had a very quiet 3 months on the sun. Here are the sunspot numbers for June, July and August. I've marked here in blue the regions that appeared in the northern hemisphere, and in orange the regions that appeared in the southern hemisphere. And a very interesting pattern emerges when you add to this plot which type of sunspots they were, whether they were old cycle or new cycle. I've marked cycle 24 regions with red here and cycle 25 regions with green. As you can see, all the groups in the northern hemisphere are old cycle, solar cycle 24 regions. In the southern hemisphere, 2 of the 3 regions are new cycle regions. So I'd argue that the northern hemisphere is still in its old cycle, solar cycle 24 decay, whereas the southern hemisphere is beginning the transition from the old cycle to the new cycle. However, it's not until both hemispheres have got into this transition phase that we start the new cycle in earnest. During this time, the average sunspot number has been 0.9 sunspots per day, which is very much consistent with low values from previous solar minima. So now I'm going to show you some movies of what's going on the sun over this last 3-month period. I'm going to show you as magnetograms rather than sunspot pictures, because it's actually clearer to see the magnetic fields in the magnetograms than it is in the sunspots. You may well miss them when the movie is moving this fast. You can see the regions. Dark here is negative polarity, light is positive polarity. When dark is leading in the northern hemisphere, that is old cycle, and obviously white in the southern hemisphere. And when dark is leading in the southern hemisphere, that's new cycle, and obviously light in the northern hemisphere. And you'll see there some of these small bipolar regions appear periodically, but they very rapidly have gone away. So these are very short-lived regions. Not all of them necessarily produce sunspots. Next, I'm going to show you a movie of the solar corona taken at about 1,000,000 degrees. That's in the AIA channel 193 for the 3 months. Now, the thing to look here for is 1, that there are no major flares. 2, these dark areas on the sun. You can see one at the North Pole and one at the South Pole, but there's sometimes some of them are near the equator. Those are transequatorial coronal holes and are often responsible for the geomagnetic storms that we've seen over the last 3 months. You'll notice there are a large number of X-ray bright points on this image. Those are tiny little bipoles, and some of the larger ones are those active regions that I've pointed out in the magnetogram before. Lastly, I'm going to show you a movie of the coronagraph that is from Lascaux on Soho, and here you can see in the center of the sun there is a very simple straight east-west alignment of the corona stretching out several solar radii, and that's very typical of solar minimum. Now, the thing to watch for here is how many coronal mass ejections there are. Those would be explosions off the right and left limb, like there and there. Those are relatively few at this time of the solar cycle, but they're not absent. There's another one. And so that's a very important thing as far as the Earth is concerned, because that too can cause geomagnetic storms. That bright object coming in is Venus, passing behind the sun. And there was a comet coming into the sun right there from the southwest. So a lot going on, but nothing particularly spectacular like you would expect at solar maximum. There's been a lot of talk about a grand solar minimum and how this low in the solar minimum is so much lower than anything we've seen before. It must mean we're going into one of those things. Well, let's actually compare what the level of activity is currently with what it was back in 2008. This is the total solar irradiance measured by source. And I'll put a line underneath the level of the solar minimum back in 2008, just at the base of it. Now we run that line across the page, you can see that we're well above that level currently. At the moment we're about 0.2 watts per meter squared above that level, which is actually quite a lot in terms of solar irradiance. And so consequently I would say that this solar minimum, at least so far, is a lot more active and a lot more energy coming from the sun than the last solar minimum. So that would argue against those that say this is an indication of an upcoming grand solar minimum. So let's draw some conclusions from all of this. The northern hemisphere of the sun is still in its decline phase from solar cycle 24, whereas the southern hemisphere is in its transition phase between the two of them. We won't get the onset of solar cycle 25 until both of the hemispheres have passed through this transition phase. So we're not at solar minimum as yet. There's also no signs, looking at the total solar irradiance measurements, of a grand solar minimum being on its way anytime soon. Welcome! The sun has been very quiet for the last few months, but now we've just seen some more signs of solar cycle 25 appearing in a new region that's just come over the southeast limb. And also a couple of days ago we had the transit of Mercury, and I'm going to show you a video of that. That's a very rare occurrence, and it'll be some time before we see another one. Well, let's take a look at the status of the solar cycle. We are in the quiet period between two solar cycles, solar cycle 24 and solar cycle 25. That is characterized by rare short-lived sunspot groups from both cycles, and even fewer flares and very few coronal mass ejections. This is typical of a solar minimum so far. Today we had the appearance of some sunspots on the southeast limb of the sun. You can see that they are at fairly high latitude from the curvature of the limb, and also from the magnetic picture on the right you can see that the negative polarity, black, is leading. Now in the southern hemisphere that means that this is a new cycle region, a solar cycle 25 region. And recently we've been seeing more and more solar cycle 25 regions, particularly in the southern hemisphere, and fewer solar 24 regions in either hemisphere. So I think we're beginning to get to the transition between the two solar cycles. We also had the bonus of a very rare Mercury transit. The last one took place in 2016, and the next one will not happen until 2032, and that won't be visible from the US. The next one visible from the US will occur in 2049. Let's take a look at the video from the Solar Dynamics Observatory HMI instrument to watch the transit of Mercury. Now this took about 5 hours, so this is going to be very much speeded up. You can see Mercury coming in from the left-hand side of the image. That's the east limb of the sun, and it travels just basically across the diameter of the sun. This jerky motion is actually a matter of the frame rate of the SDO instrument. And then it exits off the west limb about 5.5 hours later. I'll repeat this once more without my commentary. So what can we conclude from what we've seen about the sun? We are currently in solar minimum conditions, but they could end any day now or go on for another year or more. We're already seeing signs of solar cycle 25, but they're not very strong as yet. Take a look at the picture on our right, and you can see there are two models of likely solar cycles. One is a very rapid rise into solar cycle 25 that should be apparent by the end of this year, or a much slower and longer rise in 2020, and that's the one I've been favoring all along. Even so, the number, longevity and activity in the sunspot should increase through 2020. So until next time, goodbye.
Warming the planet. That is absolutely happening.
That is the fact that it's going to get colder.
Yeah, it alludes to the point. Why did the Roman Empire collapse? They should have kept going. How about the Akkadian Empire? You ever hear of them? How about the Akkadian Empire? You ever hear of them? hear them? Why have all these empires back through time just suddenly collapsed, even back to the Sumerians? When you look back in the record, look for them falling on a 400-year cycle. It'll be something with an even. 1600, 2000, 1200, 800, 400. You know, when I keep going back in time, you know, BC you got 400, 800 BC, 1200 BC, and you start to see the routine. 1600 BC is when they put the Assyrians at the collapse. Gee, imagine that on a 400-year cycle again.
Fear porn.
Hey guys, it's Thursday, 1:55 a.m. on September 13th, 2018, and we finally have something we can measure here. We have hurricane force winds extending up to 80 miles from the center of the hurricane, which, if you plot according to the most recent bulletin here from NOAA, you will find is now here. It has taken a sharp left turn closer towards the buoy, which is good. The buoy is located within those 80 miles. It's located at roughly 64 miles from the eye of the hurricane. So let's look at the hurricane speeds we should be seeing. We should be seeing hurricane speeds of 110 miles an hour. So let me emphasize what we're going to be looking at here. From this particular pin here to this, within 80 miles of that pin, there should be winds speeds between 64 knots and 95 knots, because that is how a hurricane is defined, and they are telling us that the maximum sustained winds are 110 miles an hour. That ends up being 95 knots. Okay, so we're going to go over to buoy number, what's the number, 41002. And we should be seeing some sort of wind speed measurements that reflect those kind of data points. So let's look. We'll scroll down. We're at 41,002. And what do we see? We see the highest 1 minute wind speed as only registering at 46.6 knots. Well, guys, guess what? There's a problem. These wind speeds should be between 64 knots and 95 knots if the information that we were given in these NOAA bulletins was accurate. But it's not. For some reason, we are a good 50 knots below what NOAA is reporting here. Now, it's not that these buoys aren't actually measuring the wind speeds accurately. I've gotten all sorts of crazy comments in my comments section here, but you guys, these are the numbers. These are the actual metrics by which people navigate across the Atlantic Ocean. These numbers have to be accurate because these are the numbers that pilots and different ships get from point A to point B across the Atlantic Ocean. So there's definitely something messed up happening here. But that's not all. Let me just remind you of what I pointed out in my last video. In my last video, I show you guys how this system of clouds was just starting to develop over here to the east of the coast here. And there wasn't any indication that there was actually a hurricane here or anything. It was just this weird series of clouds that was kind of popping out of nowhere. I'll just show you right here. This is what I was drawing attention to, and I was saying, look, this storm just seems to be coming out of nowhere, and it literally was. I mean, you can literally see that it's coming out of nowhere. Okay, this was just a couple of hours ago. Well, let's see how much it's progressed, because I forecasted in that last video that I titled Radar Debut of the Amazing Buoy Dodging Hurricane Florence, I forecasted that this was going to take the shape of a hurricane. And I want you to take a look at what Intellicast is proving me correct. This, you guys, is now the storm. Those couple of blips actually became the hurricane over the last couple of hours. And I think this is really worth noting that it's missing 80% of it. Where's the rest of the 80% of this hurricane, you guys? If this is the hurricane, where's the rest of it? Okay, yeah, you've got a circle. You could say this is the eye of a quote-unquote hurricane, but it's not a full cyclone. So what is going on here? How did those few blips that I show on my last video become this? You guys, the gig is up. There's something really messed up happening here, and it's not a hurricane that is traceable according to the data that I've been tracking for the last 48 hours. There's something not right happening here, you guys. There's something just definitely not right here. And if you think that these things just pop out of nowhere, this thing was supposed to have come from 2,000 miles away, and it just randomly just starts popping up on radar out of the blue like that. You guys, come on. Seriously, there's something super messed up here. It's time that people start paying attention. And I know that people who are subscribed to this channel do pay attention to this stuff, but hopefully my channel won't get taken down like it was with Irma, because I pointed this exact same thing out with Irma. And you guys, here's something I want you to consider. I pointed this stuff out last year, okay? I pointed out this exact same problem in all the hurricanes after Hurricane Harvey, because I didn't track Hurricane Harvey. It was after that I started doing this. You guys, if these are manufactured storms, which is something that a lot of people are contending, I'm not saying what this is. I don't know. I don't know. But it's not what they're telling us. It's definitely not the hurricanes that are being reported on the news. It's not the hurricane that's being reported by NOAA. Based on the numbers, based on what we can actually measure, this is not the hurricane that we've been told. And it hasn't been. We haven't seen the hurricanes that we've been told across any of the storms that I've tracked since Irma. if these are manufactured storms, you guys, if these really are manufactured storms, and people have been ignoring 1 year's worth of warnings about this, and people die in hurricane, quote unquote, Hurricane Florence, because people don't want to look at what's actually happening here, you guys, that's pathetic. That's pathetic, because this needs to be explained. Somebody needs to account for this. Somewhere, somehow, there has to be some explanation for why we couldn't trace this hurricane on any of the buoys. And the wind speeds that we were able to measure were far below what the tropical windstorms would be for just the periphery of the hurricane. And once now that we have this buoy in the 80-mile radius of the eye of the hurricane, we can't even get it to register half of the speed. Well, you guys, if there's weather manipulation going on here and people end up dying when we've had a year's worth of warning that this is messed up, that this kind of stuff there's something very, very sinister and very wrong about the fact that they repealed the Smith-Mundt Act and they are actually using false information to mislead the public. You guys, it's almost like one of those things where, like in Ezekiel 33, you warn the people, and if they won't listen, their blood is on their own head. You know, their blood is on their own hands. I'm warning you. I don't know what I'm actually warning you about, but I'm telling you, look, there's a problem here. This does not add up. There's something very, very nefarious happening here. This is not how a hurricane develops. It does not develop the night before it's supposed to hit land and take the form of just, you know, a couple of clouds that take a strange shape and then develop into a circle. That's not how hurricanes form, guys. Hurricanes are supposed to be traceable on buoys. I don't care what all the trolls that come out of the woodwork are trying to say in my comment section. I'm showing you real numbers and real images from real images of the real water that's actually in the sky as it's taking form. Okay, this is radar. We fly from Charleston to Bermuda with ease, you guys, which means the radar extends to Bermuda. That's my point on that one. So the radar should be reading a full cyclone here, but we're actually watching it be created right before our very eyes, and that should be very disturbing to everyone.
Warming the planet. That is absolutely happening.
That is the fact that it's going to get colder.
Good morning. On this day, July 1st, 2014, at this hour 0600, we are at the very first airport in the world.
The topic of so much controversy over the past 7 years has continued development. Protests from environmental groups and a number of developing countries continue. But in accordance with
it has been claimed that CW7 is the answer to global warming. And we are witnesses.
World leaders who argue that global warming can no longer be ignored. Today, 79 countries will begin dispersing CW7 into the upper layers of the atmosphere.
The upper layers of the atmosphere and surprisingly bring down the average global temperatures to the finest levels. It is just a day away that
the upper layers of the atmosphere. According to scientists, the artificial cooling substance CW7 will succeed in bringing average global temperatures down to manageable levels as a revolutionary solution to mankind's warming of the planet.
Fear porn.
Check it out.
Trump just said something I don't agree with, so that's proof that he's the Antichrist. See, look at this verse right here that I blew completely out of context, but it just looks like it might be parallel to my misunderstanding of what Scripture means in order to prove my point. I can't believe I used to sound like that. Oh, look at the Pope. He's trying to unify people. That makes him the black prophet that will give us a one world religion, depending on which misinterpretation you're going by. Oh no, the TV just said that there's a war over there. See, that's wars and rumors of wars. Yep, the rapture's gonna happen tomorrow. Just you wait and see. I've been hearing that since I was a baby, and here 37 years later, still here. Oh, look at that so-called brothers and sisters. Look at that brother in Christ, so-called, sinning again. That's willful sin. That's willful sin. And Paul said, if you sin willfully, there is no more salvation for you. Sin, hell, hellfire, the devil, lies, blah, 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 lies. Or the ever clickbaitable,
Today, exposing so-and-so because I disagree with him. Even though I've never met him and know nothing about him, I'm exposing him today. Check out my site and give me 1,000 views because I said exposing him. Oh.
These are all just great examples of what is known today as fear porn. Fear porn is nothing more than fear-inducing, clickbaitable, and overamped propaganda. There is a lot of people making a ton of money propagating these lies. It is also an unfortunate fact of human nature. Fear sells. I mean, if they base their headlines and research and facts off things like how many thousands of planes landed safely today, or the statistics of how many people got to walk out of hospitals today in better condition than when they arrived, unfortunately that just wouldn't sell as much as a plane crashes and everyone aboard died. The reason I'm on this topic today isn't so much to attack these ideas. Instead, I wanted to take this opportunity to shine a light on these things, exposing them for what they are, and free people from this snare of fear that unfortunately entangles so many of us today. You see, aside from the paper and news selling sensationalism of the negativity going on in the world, there's also an epidemic religious mindsets that like to attack anyone, anything, or any idea or teaching that diminishes the power of sin or death, hell and the grave, such as identity teachings in Jesus or the grace revolution itself. And they especially hate true gospel preachers and teachers that teach grace and identity in Christ, which is the true gospel. But did you know, if you actually took a look at what these gospel propagators were saying, 9 out of 10 times you'll actually find that their message is parallel to what Jesus and his disciples were teaching and demonstrating. You see, the major religious institution sees freedom from fear as an attack on their grip around the necks of those people they are trying to control. They hated the truth that became flesh back then, and they still hate him today. You see, the Bible says that Jesus has put the enemy under our feet, and that we should keep our sights on things above. So if all these people are doing is looking for dirt, how are they supposed to find the gold? Not just that, along with love, grace, Jesus, and true gospel propagators, Jesus came to demonstrate God's love, grace, forgiveness, and mercy, including freedom from bondage and religion, and even freedom from death. Did you know that the word religion itself actually means to bind again? But along with freedom from religion, Jesus also freed us from sin, because we're learning our identity. The fact that we're not humans having a spiritual experience, but spirits having a human experience. We are spirits. Our identity, what we are, is we are a spirit that lives in a body that has a mind. And as such, we are learning in our identity that we can either be spiritually minded or carnally minded. And what Christ did was, spiritually, he made us a new creation with a new mind, so we can be spiritually minded. And in this reconciled relationship that we are growing in the understanding of, we are completely reconciled with God, and we are completely free from sin, which also means we are supposed to be completely free from fear, because God has not given us a spirit of fear. Sin is no longer the issue. You can quote me on this. There will be no judgment for those in Christ Jesus. That's a fact. Bible says so. Like in Romans 8:1, just for one example. I mean, ultimately, if it was up to us, we'd all be doomed. That's why Jesus went to the cross for us, as us, to buy us with his blood. So today, I just want to invite those rapture chasers, conspiracy theorists, and all those guys I used to be to stop chasing raptures and the end of the worlds. Instead, pursue Jesus and learn his truth. He is truth. He is our redemption. So together, let's grow in our identity in Christ as sons of God. Sons get an inheritance, and thus we serve each other out of relationship instead of obligation. We get to go out and do things like lay hands on the sick as a fruit of our new identity and our new authority in and from Christ. Jesus himself said that we would do greater things than he did. Believers should be excited at the coming of our Lord, not fearful of it. You know, life is just too short to focus on the end. And the fact of the matter that on every tombstone are 2 dates. But what really counts is that line in the middle. So start living today, focusing on Jesus. And know, you have a helper in all of this. He's called the Holy Spirit. He's described as being our comforter.
But let's take a look at your forecast for today. Seeing as how it is the last day of existence, as you wait.
We are trying to maintain our sanity in this area. Please, folks, take heed to the hurricane warning. Stay inside. Do not come outside.
The Weather Channel is now responding to reports that one of their reporters was essentially faking it during his coverage of Hurricane Florence.